That's it. We are live. Today is Friday, the 28th of September, 2018. End of September already. Anyway, on the panel is Patricia, Flat Earth Dude, and Astral may join. We've got Chris UK and MrThriveAndSurvive. Hello.
Hello, all. This is starting to be a habit, Karen.
Oh, we love having you on anyway, Rich, and I know that you're very interested in some of this stuff, so it's a pleasure.
Yeah, it's very interested in Chris's work. I think it's fascinating, and it's an absolute reality check that what he goes into and shows. If you don't mind, if you could start from the beginning, Chris, with what you do and explain it to everybody, it'd be a good refresher for me too. It's fascinating. We'll get into different things like we were talking about just before we came live, like how people will use angular momentum as an argument, which makes no sense. Well, we'll get into that.
Yeah, well, the basis of it is that everyone looking through a set field of view will see a certain thing from a certain distance. So if I'm in England looking at the stars, a set of stars through a set field of view, there'll be a certain size in that set field of view. But if I'm further away from them stars, then they'll fill the field of view less. So that shows that the stars are close, plus with the varying distances, they're filling the field of view a different amount. So what I'm trying to do now is set up my P900 so I can take either it through a set field of view through a frame, or just set the camera up and take a picture of a constellation of stars and compare it to someone else in another part of the world and see what differences there are. And with that, we can work out what's where and how far away it is. It's just taking the photographs and comparing them with each other. So the early experiments are just to take photographs of the plough from two spots on the Earth, compare them. So if there's a difference in a field of view, then we're onto something. If there's no difference, then we'll have to look at something else. But early experiments looking at other people's photographs, there's a difference in the field of view. Well, obviously you've got the atmosphere, you've got everything else that messes it all about. So once the video was put up on John Smith's Global Eye, I got a lot of interest about it, not just off flat earthers, but of people who are globe believers, saying this is a proof, you're going to prove it's a ball. So they're going out trying to use this technique now to prove it's a ball. And I set them a challenge to get a telescope and find a group of stars furthest from Polaris they could see and track across the sky. Focusing on the stars as they come into view, hold the focus, hold the zoom, and note how much it fills the field of view and track them right across the sky. And as it's tracking across, note how it fills the field of view. And quite a few of them going, yeah, right. And some of them are going to try it, but not had anything back off them. So that'll be interesting to see if anything comes back off the ball believers with the telescopes to track one set of stars across the sky. Because obviously with atmosphere, I live in the UK and it's so cloudy, I've not had a chance to go out and try my ideas out for properly. One night I've had in the last couple of weeks. So I'm stuck at the moment. I need some clear nights to work out how to set my camera up, how to set the photographs, and best way of moving forward on it. I've got a lot of interest from, well, about 5-6 people from around the world who want to do this with me. So I'm trying to work out how to set the camera up so everyone with a P900 can use either this or just the camera and take the photograph of a set of stars. So we'd all have to agree what set of stars it's going to be. I don't think it matters what night you do it on too much. It's just the constellation of stars. It should always be the same size from wherever. So if they're different, there's a problem.
So are you expecting a difference in the field of view? Different locations?
Yes. If the stars are closer, which we believe they are, then yes, you'll see us. But there's obviously atmosphere, positions, and other things to take into account. But I'm expecting a change in the field of view.
He's going to find it, though, because I know when people were talking in Arizona and they said how big, say, the Big Dipper was in their sky, so stretched across the sky, it goes around my house. And I went to Denmark and it was smaller. It was over there. It was further away. It wasn't going around my friend's house. So he will.
So what you're saying, Chris, is that the stars, the constellations are so close that even a change in latitude on the Earth would give us a different field of view.
Well, if the stars are 4,000 miles away, and you can change 2 points, one's 1,000 miles difference from that set of stars than this one, you're going to see a difference in a set field of view. It's going to fill the frame differently. So you've got the Earth there from one spot, take that photograph, and someone 1,000 miles away is going to have a photograph like that through a set field of view. So 2 photographs, reference them, and if there's a change in size within the field of view, then there's a distance difference, or there's something else that accounted for it, atmosphere possibly. So it's a simple way of referencing how far things are away, and then you'd have to take into account all the atmosphere and everything else. So you'd have to have quite a few photographs before you could say, right, this is what I'm getting. So you're basically measuring perspective. So
this is different than what I saw. What I saw, you were talking about the different speeds that stars and the sun and everything would have to go by a certain field of view in a certain amount of time, depending on your location.
Well, it wasn't a set time. If you've got two fields of view separate, say 1,000 miles apart, and the stars are tracking across the top of it, as you've taken photographs of the 2 fields of view, the 2 fields of view will look the same when it's the same distance apart. So you can track 1,000 miles apart, 2 fields of view, photographing up that way to one set of stars, and if they're both still in the field of view the same, then they're the same distance from both. Yeah?
Can I be very, very rude and tell you to tell your missus to be quiet in the background there, man?
Yeah, it's a little bit noisy, the dishes. Hi, Astral.
Hello, Astral.
Hi, Rich. Nice to see you again.
Yeah, good to see you.
Yeah, I'm a bit late, so I was busy on YouTube here.
Yeah, I saw you uploaded a video earlier.
Oh, yeah, that was just a little wibble wobble. Yeah.
See, I'm confused. I thought, Chris, I thought your work actually centered around the idea that the stars would have to be traveling faster through a field of view if you're at the equator versus in the UK. Is that not where it started?
That's not quite where it's. Yeah, that was my first video about. You're mixing the 2 videos up with the talk in the garden. Was about speed relative to position. All right, so that's sort of gone out there, and it's sort of no one's picked up on it. So I've sort of got onto this now, separate from that. Yeah. So now I'm onto set fields of view, taking a photograph, because this comes from that talk and talking to other people.
Okay.
Because they were going on about angle of view and everything else. I said, well, how can I set a view? So I can set it with a frame or with the frame of a photograph. But I thought a frame is possibly the easiest way of doing it. So it's basically to find out if the stars are close or they're far away. That's it. And then once we find out there's a change in fields of view, then we know they're quite close. It's got to be, because you wouldn't get that change in the 2 fields of view unless you're close.
Yeah, you would have no change, I would think. Not with billions of light years.
No, you don't. They wouldn't, would they? So setting the fields of view and getting people to take photographs around the world. We've got P900s. Set it as a reference. Then we can compare all the photographs. It's just getting this. I want the simplest camera settings I can do, and the simplest way of setting the camera up with the field of view. So everyone with a P900 will be able to do the experiment and send the photographs in. No, I was hoping that hopefully people for people be able to take images.
I can set it up. Yeah, I can set it up to where we can do that.
Yeah. So once I get this set up, as soon as I get about a week's worth of stars, I can set it all up and work out how to do it best, and then possibly speak to yourself or contact yourself. Do you think this is a good idea? Because I'm not an expert on cameras, and I'm not expert on astronomy. I'm just like most of us trying to work all this out as we go, and we're becoming experts on things by studying it now afresh, which is a good thing in a way, because you're not corrupted by all the knowledge from other people.
Absolutely.
So up to now, I'm waiting for some clear nights, and unfortunately in the UK and in Rochdale, it's not clear.
Are you in Rochdale?
So I'm a bit,
Chris, are
yeah.
you in Rochdale? No way, Sherlock. Seriously.
Why, where are you?
After the chat, no, we need to talk, because you need to do something for me. I have a friend in Rochdale. You need to help me, brother. Anyway,
Right.
that's regardless. Carry on, please, because I also have something to hand in what you're on tonight about what you're doing with photographing. I also have an idea that I've talked about a few times, but maybe you guys can help me with it. But carry on, Chris.
Yeah, so really I'm stuck with the fields of view at the moment, because I need to get the settings right. So as soon as I can get the settings right, how people can do it, then I can do a simple video, get Karen's put it up, then people will hopefully get the images in, but make it as simple as possible. All right, so I've got that field of view idea, but I've come up with another idea as well, because I want to track the celestial equator. So do we all know what the celestial equator is?
Mm-hmm.
Yeah. So
explain it anyway, Chris, because some people won't know.
Well, when you look at the stars from the equator on a ball, you see the stars. The line of stars is right around the middle of the ball or Earth. And that's called the celestial equator. It's equivalent to the equator on a ball, but it's the equator in the stars. So supposedly as we're spinning, it's a line of stars. So from your latitude, you can work out where that celestial equator is in the sky. And I want to be able to map the whole of that sky across, because it's the same every day. And we can map the star trails from one side straight to the other and compare and contrast what the shape of the star trails. Because I've got an idea on how possibly they're working. So has anyone seen Super Clever Turk, the video he's put out?
Mm-mm.
No.
Not me.
Who
is it?
Super Clever Turk. He's not got very many videos.
Super what Turk? Clever?
It's Super Clever is one word, and Turk.
Thank you.
Right, he's got a really interesting video on the sun doing a figure of 8 and explains it all, how the sun moves around on a figure of 8. Right, and I come up with the star constellations. Can you see that?
Yes.
Yeah, moving round that way.
Yes, that's great, because right there you're showing how star trails. Now you're talking about two hemispheres in the sky, right?
Right. Well, I'm talking about the North Pole, the South Pole, and the celestial equator in the middle.
And you're showing how the stars diverge away from each other, which is brilliant.
So they're moving around like that.
So what you're showing right there, just for people watching, that is impossible if we are the ones moving, because you can't have stars diverge.
No, you can't.
You can't if you are the one moving. You can't have diverging stars.
Yeah. So this celestial equator here, we can all see from different points. It should be slightly different shape as we move as well. So if we can map that and that, it's quite an easy, simple way of doing it. You can set a platform up at your latitude and work out where the equator is, because it's 90 degrees from that.
Sorry, brother. Please, can you hold that picture up again to the screen, hold it still, and explain exactly to people that are watching exactly what it is they're seeing there, because most people are not aware of what you're holding up. You know,
and yes, and it's extremely important what you're showing, because it's a ball buster for sure.
It's a ball buster. Well, basically, it's based on a current passing through a ring of wire, right? And these are the magnetic anomalies. This is demonstratable, right? So you've got a current here, and you've got North Pole and South Pole.
So two poles,
and in the middle, right? So you've got the stars going revolving that way and revolving that way. Yeah. Now, what would you expect in the middle of these two poles? An anomaly, a magnetic anomaly. Yeah.
Mm-hmm. Yeah.
So I found the anomaly.
Now, what you're holding up, is that actual star trails, or is that?
No, that's my interpretation of the star trail. I've used it's called a Wolfram Demonstrations Project. A demonstrations Wolfram, WOLFRAM.com.
Because that's exactly what the stars do.
Pardon?
That's exactly what the stars do. They do that diverging.
It doesn't show you the stars, but it shows you how increasing the current through this makes the magnetic field like that. And you can increase the current, increase it, and increase the ring to get that effect.
And what I'm saying is, star trails actually show that that's what they do.
Yeah. All right. So I'm trying to work out why we see what we see in the sky from these points.
Okay.
So the magnetic anomaly I've found is that one, the Bengi magnetic anomaly in the Congo, and it's smack bang on the equator.
If you can move it away from the, there you go.
All right, so it's there is the anomaly. That's NASA and everybody tells you about this anomaly. The compasses go berserk there. So if that,
can I ask, is that an increase in some sort of magnetism that right there, or what is it that you see?
We've seen it before, Astral. We've seen it before. There's a 0 point there.
Yeah, so what I'm saying is you've got a positive and a negative right in the smack bang in the middle of them. The compasses are going to go berserk. And that's the anomaly in the middle of the Congo, which is right smack bang on the equator. So you've got a positive and a negative anomaly here that's messing about with compasses as soon as you get a compass out. So that's the name of the anomaly. There's plenty of information about the anomaly. People even go there for healing purposes. That's something I just found today. So did no one know about this?
I didn't know the name of it. I knew there was a magnetic anomaly there. There's also one near New Zealand, right?
We didn't, but we do know.
Yeah, but that seems to be the biggest anomaly from what I can find.
Can I just ask you, Chris?
Yeah.
You're aware, obviously, you're from England, right? And I know somewhere in the UK, I don't know exactly specifically the road it's on, but there's a road and it's going uphill, but balls roll uphill. There's a road, and it is a gradient that is rising, and balls will roll uphill. Even if you put a level on it, it's not level. You can see that it is physically going uphill. And that must be one of them as well, one of these magnetic anomalies. You've heard of it, haven't you? There's loads of them all over the earth, man. But one of them is in the UK, I know. And you can see it, and it looks crazy that things roll up the hill.
Well, if you look at where our birds migrate, do they follow this magnetic anomaly? Right, super clever Turk has picked up on something with his son doing this. and that bees do the same. You'll see it on his video. You know, he doesn't do it 100% justice, but he gets the idea out. And if you look at birds, I've got a flock that fly over my house, and they all do a figure of 8 when they go out. They don't come back on the same route. Go out that way, and they come back this way. I'll be following the magnetic lines to guide where they're going. So birds migrating. So that's what I think we see in the sky. A flattened version of it above us. And we see different things because of perspective. So perspective is the next point I'm trying to work out. I've got an experiment I need to do on a big straight run, a few miles long, to work out how perspective works. Because you know how latitude works and the angles. So, I mean, if Polaris is, say, 4,000 miles high, as you move back through the angles of latitude, what you're measuring is perspective. The Polaris is dropping. I've drawn a chart out, it's quite big, but there's a pattern as you come back in your degrees of latitude to what you see fall down. But I need to do this in the field to work it out properly.
Hey, Chris, Deep Proxy in the chat room said, do you know anything about 360? The stuff that stand out?
No, I don't. So always when you do your own thing, you try your best to catch up with everybody, but you're mixed up in your own mind and try to get hold of information of other people as well. So you miss quite a lot.
Can I, and you as well, Rich, and anyone else in the chat, I've been looking at, we've got a guest on soon called Jazz from Australia, and he's been doing a lot of work. If you look at his work, you'll see it's correlating a lot with what you're saying or seeing. And I can understand the relationship between what he's drawing and what we're observing through our night sky and stuff. You know, I'm so excited to get him to come. I want to hear what he's
I've asked him, Astral.
Yeah, he's going to come, isn't he?
Emailed him. I'm waiting
for
him
I'd love to come on with him, definitely.
But there's a big correlation between what you're seeing and what's been happening, and yeah, it's just they coincide anyway, and it will be interesting. Yeah,
I came across his channel a couple of days ago, and I've subbed to it, but I've not actually watched any of all the videos because I thought that them drawings look similar to what the lines I'm going through. So I'll have to watch his stuff properly. So yeah, he's definitely down the same lines. He's not got many videos on, but it's interesting stuff that he's pointing out. But I've got a big experiment I want to do over a very straight run. I want to measure perspective using a sextant, but massive. I've got made a big sextant, and to mark the angles and distances when you get to certain degrees of latitude from an object up in space. So not up in space, but I was going to get a massive bunch of helium balloons, get them as high as possible on a nice windless night or day, and measure perspective from that point. So we can use it. So map it out and get a proper reading, do it scientifically properly, and get a group of people together to work this out. So do it at different heights. See perspective, because perspective works on height and also on distance apart. It works the same way. I know atmosphere work alters what you see, but when you talk about perspective to ball believers, they say it's nonsense and rubbish. Some of them, they haven't got a clue about it, and it's not taught in schools. So and if you try and find out about it on Google, the information is not there. There's no simple graphs explaining it. It's all complicated maths. It doesn't need to be. So I'm open to do a simple experiment, get a group of people together to do. It's going to take about 5 people tops probably to do this experiment, but find a nice. The Bedford level's probably be ideal, but that might happen. I don't know. Just getting a group of people together to do this perspective experiment. So it's exciting times because I've got quite a few big ideas, and I'm trying to work them all out at the same time.
Now, on your helium balloons, are you going to tether them, like have one with maybe 100 100 feet of cord, and then, then maybe 200?
Yeah, I've got tons of helium balloons, the foil ones. And I've got a big tank of helium already. It's just a matter of getting enough balloons up and put some highlighted on the top. Set distance. Well, you don't even have to set the distance. Just get it as high as you can so it's steady, and then work from that. So obviously, it's not a windy day or ruin it.
So you're looking for a cloudless, windy day in the UK?
Well, yeah. Well, a windless. Well, you do get windless days in the winter, so it might be winter. So
okay.
I don't need the stars. I'm making my own pole star out of the balloons. So just no wind, please, and a group of people to do it.
I'm just thinking maybe it's something I could do also. Now, does it matter? I'm thinking about getting the B700. I know that wouldn't correlate with the P900, but at least I could, with whatever camera I get, I could, I'm in the desert. It's clear almost all the time. I could do some perspective, with tethered balloons, send it up 100 feet, then 300 feet, 500, whatever. Take pictures and
measure latitude, your angles of latitude from it, and measure the distance between each mark as you go back.
Okay.
So because latitude is it 10 degrees? What's that equivalent to in distance on the Earth?
That would be
610
miles, something like that.
So if basically your angles should change to every 610 miles by 10 degrees.
Yeah, this is sort of correlating with what I brought up a couple hangouts ago. If you went to the Brazilian flats or someplace like that, let's say Kansas or whatever, someplace that's flat for a long distance, and you took pictures, let's say you could see Polaris, just for argument's sake, from the northern part of the flats, measure the degrees above the horizon, then go to the southern part at the exact same time, have somebody take a picture there, and note the difference. Now, people will say that there won't be a difference because they don't take perspective into consideration. But there will be a difference because you're further away from Polaris. Now, of course, you couldn't probably pick Polaris, but some other star that you agree on, 180 miles, I think it's 180, well, let's say it's 100 miles from the northern tip to the southern tip of those flats. You could actually measure exactly the difference per 100 miles of a degree of above the horizon that any star would be. And in that case, if you go someplace where it's not flat and go the same 100 miles, you should have an additional lowering of the star when you go 100 miles south because of the curve. But if you don't, that'll show that it's flat. If you follow what I mean. It's a hard concept to try to explain.
Well, I get it. If the stars stop revolving, you should be able to measure distance from any star.
Right.
Measure latitude from any star position.
Yeah, you could even do this east-west with a certain star.
Well, you could possibly do it with these, celestial equator. You could work where that is out. You can do latitude from that.
Yeah, the photographs just would have to be synchronized at the same time. That's all.
Yeah, that's the thing. Well, if you're in the desert, you could possibly do the photo, set it up to take a group of stars starting off the north or the south when it pops into view, and keep taking photographs as it goes across the sky, but not within a set field of view, and see if there's any difference in them shots still in that field of view. So it might be easy just to get a frame, take it through that set field of view, so you can reference it when you get back and put it in your Photoshop or whatever, and you can see how it's filling that field of view.
Now, instead of having to worry about maybe a frame, have you considered, let's use Polaris again. You put Polaris in the extreme upper right-hand corner of your camera, or lower left, whatever. You pick a corner and put Polaris there, and then you look as far over as you can to the opposite side and see what's the farthest star you can see. And then from another location, do the exact same thing. Put Polaris in that upper left-hand corner, see if more or less stars are visible.
Yeah, that's a good idea. This is what I've been looking for. I'm looking for better ideas than what I've come up with. I know there is one there. You could just point a camera up and take a photograph without zooming or on auto or whatever. Because it's not that simple. But I'm trying to make it simple.
Yeah. Well, to me, that would be that'd be pretty simple.
Yeah. Well, you're in an ideal spot where you could try that out now, because I don't get any stars. So you could track a group of stars across the sky one night and take the photograph of the same group of stars within a field of view to see if there's any difference. But then
are you talking about difference as far as like I would change my altitude? See, that's another thing I have the ability to do here. I can go from maybe 600 feet to 4,000 feet or close to that in a 30-minute drive. So
well, you could if you could get a set of stars straight above you, take a photograph and then take another photograph of that group of stars. Just see if there shouldn't be any difference in a field, how that group of stars is in that photograph, how it fills the field of view. But it's set in the field of view that's important. It's having a set referenceable field of view. That's why I thought a frame's a good idea. It doesn't matter what setting. If we all use the same camera, you're going to get the same field of view.
Can I say something, please?
Yeah.
Right. It's very simple, the idea that I have as well. It's very simple, similar to yours, but we're not talking about the stars. Now I'm talking about either the sun or the moon or both. But you take a picture of the sun or the moon from the same position, same time every day, or if you're doing the sun, you can do it every 5-7 days or whatever. If you're doing the moon, you can do it daily. But you don't have to be daily, but obviously it's just going to use up more bandwidth and stuff, isn't it, every day or every other day. But anyway, basically it's this. You take a picture of the sun and the moon at the same time every day, and you have the orientation either, you have to have the orientation. It's pointing north, it's pointing east, it's pointing west, south, whatever, and whatever degrees it's pointing at when you take that picture, right? Now, if you take your picture, Chris, and I take my picture, and Rich takes his, Karen takes hers, we all have our aspect from our point of view, what we're taking our picture at. Now, if we've all got the same time, right, we should all have the same height. Then we can compare our pictures. Obviously, Rich might be living in a mountain top, and I'm living at sea level. Obviously, there's going to be a difference there, but basically, we can set the height of our moon, sun, whatever it is, the same height, regardless of where we're living. This way we can get a good picture. And if we're all doing it, let's say we're 10 people or 20 people doing it, imagine 20 people across the plane. I'm not saying they're going to say around the globe, because we're not living on a fucking globe. Sorry, Karen. We take a number of people around a plane, and we're all taking pictures with our objective facing either north, south, east, west, whatever direction it is, and at the same time, it has to be the same time every day, you're going to get this pattern, aren't you, this analemma. And what we could do then is, imagine a ring. We are the ring, the outside ring, and our analemma is in front of us. It will always be in front of us, the picture we're seeing. Now, if we were all to do that, you only take 4 people from 4 sides of the earth. What would that create? Can you see it for yourself? Can you see it in front of you, what I'm trying to describe?
Can I say something? Chris, what does it mean if, say, you got the picture back from Rich and the Big Dipper is absolutely enormous in his sky and all stretched? You come to my house and you see, oh, you can see it going around my house. I'm not sure where it goes exactly, but I know that they lose the Big Dipper. When it dips down, they lose the Big Dipper for a while till it comes back up. Whereas in the UK, where I am, the Big Dipper never goes below the trees. It's there in the sky. But I said, when I went to Denmark, it was smaller. It was over there. I had to go down her garden and look in a field, and there it was right over there. So what would that mean? Smaller Denmark, middle almost UK, absolutely enormous in Arizona.
Well, Arizona is the closest to the group of stars, and we're in the middle. Denmark's furthest away from that group of stars.
Yeah, because I just don't think we're where they say they are. We are, you know, Denmark's supposed to be northeast to me, so it should be sort of going more around my friend's house, if you know what I mean. It's not. It's down the garden and over there.
Yeah, I don't think we can rely on compasses that much. I think Rich did something on compasses and the way they've got to be altered depending on position in the world or on the world. I don't know. It's complicated.
Yeah, I would use compasses. You need to use true north or true readings.
Use the stars, I think.
Yeah, yeah. If you can see something that would, give you a perfect location.
But I think Astral's idea is brilliant, but we'd all need a set field of view, a set way of taking the photograph, all doing it the same way. That's what I'm trying to do with this. Because we've got millions of P900s out there that are getting wasted. All the research we could be doing with them cameras now.
So are you saying take a frame and maybe put it like 3 or 4 feet out in front of the camera and then shoot from that?
So you got a frame. See that? That's what I've been using to do experiments. It's not very big.
Oh, okay.
Yeah. I put the P900 on there. I've been setting up from distances away, how high, and what settings to put on the camera. So just point it at the group of stars, and you see the outline of the frame on your photograph, and you've got your set field of view. So I'm trying to gauge what that should be, this opening, gauge how far away the camera should be set, and it's got to be central to there. And the easiest way of doing that, and make it uniform for a P900. So you can set it on. Pardon?
I'm not familiar with cameras, but I keep going back to trying to come up with some way that's a little simpler. You know how people today are using infrared filters. They just screw it on. Is there any way to come up with a grid filter that can be screwed on to where it displays a grid, or maybe even displays the like an artificial frame?
Yeah, possibly. Yeah.
I guess we need some camera experts.
That's exactly what I need. Yeah. I'm not an expert. I don't.
Rich, what you're saying there, right? When we take photos of the moon, it has a percentage. The moon always shows a percentage when you take a picture of it, doesn't it? You know, it's at 90.3% or whatever, you know, full moon or. So we can go off that. When it is that night, it should always be the same. It's always the same percentage. And as long as we're basing our time off UTC, how can it go wrong? Or am I seeing something that I'm not seeing?
I'm not understanding how the like you're talking about getting the percentage of the how full the moon is. How would that correlate to a field of view?
We know the percent. We know how big the moon is by its percentage, how bright it is, or how much of the moon is showing by its percentage. When it's 100% full moon, yeah?
Yeah.
So we're all getting a full moon. Are we not? Or is it just me?
Well, the only correlation I think that might help there.
In that sense, then, if we're all getting a full moon, all we have to do then is make sure that our ball moon up in the sky, or our sphere that we're seeing, correlates to my sphere, correlates to your sphere, and that they exactly mesh in size. That way we know it's right, isn't it?
Oh, I got you. To use like a reference point to make sure everybody is synchronized.
Exactly. And then also with UTC. Now, I'm not an expert on anything like this. Stan Smith, talk to that guy, because he knows what needs to be done. He knows how he would like to conduct his experimentation and things. And I think that we should help him as well. Also, Chris, don't get me wrong, Chris, I love what you're doing, brother. But it's what we need to have, a uniformity, so that we're all on the same page, all on the same wavelength, all getting the same results we need to get. Yeah, I yield the floor.
Yeah, that's exactly what I was trying to do by myself, is get a frame of reference. We could, even if we don't use this, but this can be used in so many different ways, looking at so many different things and working things out. A set field of view. But if there's an easier way of doing it, just picking the camera up and going click. But we've got to make it simple for people. Not everyone's. I'm not a camera expert. If you're saying focal length and settings and complicated settings for people, people don't understand all that, and they don't understand how a P900 works. A lot of people have got them and they can use them, but they don't. I don't fully understand how it works. I can use it and that's it. So we need something so simple that you can just go plonk, plonk, click. That's my thoughts on it. You know, if we need experts, yeah, we need experts, people who know stuff about cameras and how they work and the best settings. I'm just flicking through the settings on the camera and trying to work out what's the best settings to use. I don't know off the cuff. I'm just winging it and trying to work it out the old-fashioned way by trial and error.
Well, I think that's maybe what we need to do. We need to put a call out to like everybody in the chat or whatever, anybody who sees this video later. If you know anybody that's a camera expert that could help with this, that would be fantastic. All we need is somebody to be able to get each one of us on the same wavelength or the same, what's the word I want to use? The same grid or the same perspective. If we can match them all together, then, you know, like Astral said, if 5.25 moons fill our screen, each one of us, then we know that we're all in sync as far as our perspective field of view. And then we can go out and actually do, you know, we have a reference point where we can go back and say, hey, this, you know, we all match this. And none of the settings were changed when we did these star observations. And screw the ball people. Who cares what they think or don't think? As long as we are happy with our own work, that we're convinced that, you know, your camera has the same field of view as my camera, is the same as Astral's camera at the same time. That's all we need to know. This is for, I'm tired of, yeah, we need to please ourselves, not the ball people. Let them just go off with their own fantasies. So we just need to make sure our scientific work is up to snuff with our standards. Screw science's standards, because they're all BS standards anyway.
Correct.
I've been in science long enough to know that half of it's bunk. When you actually do real research into what you're doing, you're like, what is this? And, you know, well, somebody did a theoretical input to this a long time ago, and it's just accepted as fact. So, you know, we need to just, like you said, just get a frame of reference that each one of us agrees on. And I can set people up so that we can each have a password or whatever to upload stuff, people that are involved in this, so we can have a data collection center. I actually used to do that, believe it or not, with insurance claims. I used to host a website where people would go out in the field, take pictures of accidents, and they were all uploaded to the same spot. And then you would have a judge actually look at that. So he didn't have to leave, you know, it was all done in one central location. So I can set up something like that again. It's been a long time, but we can do it. And then we can compare everything and timestamp everything and get it going. So yeah, we need to connect so we can set that up, and let me know exactly what you need. But I'd be interested in doing it myself. You know, even if I don't buy a P900, I understand you can rent these cameras.
Yeah.
So,
well,
anyway,
P900 is the ideal camera because flat earthers all over the world, and they're the ones that will do the experiment.
Mm-hmm. Absolutely.
I went into a camera shop. I went into a camera shop this afternoon, and I said to them, "Hi, how are you?" "Oh, I'm okay, thank you." And I asked them, "Do you have the P1000?" "P1000? What's that?" "Nikon P1000. Gets on his computer, tap, 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 tap. He was in there, I think, maybe 10 minutes, looking. And he said, "No, we don't have it, but we could probably get it, like, you know." And I said to him, "I can't believe you can't stock it, man. You're not able to buy them anywhere. They're flying off the shelves. This is the world's best camera." And he was looking at me like, "What?" And the people in the shop were looking at me. I was very loud. I said, "This is the camera that proves the earth is flat." And then I went out of the door.
You run out.
Like that, man. Try that.
And they were like, "Don't let the flat door hit you in the butt on the way out," right?
It's exciting times. More people are waking up pretty fast.
Yeah. Now, have you had anybody else work with you yet, Chris, with these photographs or setting things up, or is it just you?
It's a one-man band. You know, I'm trying to get together with people that understand how these things work, and it's hard work. Trying to get. That's why I come on, Karen. Trying to get help, basically. That's what I need. I've got that many ideas popping out of my head. It's unbelievable.
Now, we're going to have to meet when I come there next year. How close are you to where Karen is located?
I'll come down and see you, mate. No problem with that.
Alrighty. Awesome.
There's going to be a party at my house.
Okay.
Well, I'll bring our P900s and we'll go to different parts of Karen's yard and take pictures. We'll watch the Big Dipper go around your house, Karen.
Oh, yeah. I just think that people are amazed because, you know, you take for granted your sky, don't you, when you see it every night? You know, like I started to notice things when I was going on holiday to Turkey, that everything sort of just looked a bit different and a bit bigger there, you know, or oh, there's the Big Dipper there, or whatever. The Big Dipper is the thing for me. But like, yeah, if it's so big in your sky, you're not seeing all the stars we see then, Rich. Not so easily. They'll be there, but they're right over there. Nearly everything is above my head.
Yeah, you know, and I've got a theory, maybe I should keep it to myself, but I think at least some of the stars in the northern hemisphere are mirrored in the south, or maybe the south is mirrored to the north. I don't know if anybody's seen the video. Somebody did a video, pretty good one too, and I can't find it, where they showed that the exact same configuration of the Big Dipper is actually in the south. They call them different stars, but it's a mirror image of it, and the proportions are perfect. So I think that's something we need to look into. Maybe we're seeing a mirroring of the northern stars in the south. I don't know, at least some of them. But you know, from a hangout that you did a long time ago, Karen, I'd love to find that photograph again where it shows that not all the stars reflect in water, which is an amazing thing. And even some of the brighter stars, they don't reflect in water.
Yeah, that's strange that I've seen that too. Karen, can I just interrupt you that lifting the lid is in the chat and he wants to come on board?
No, Astral. He's saying he wants to come to the party.
Well, he can come on board if he wants.
He's asking to come to the party.
Invitation only.
He's invited.
Oh, very good. Is it bring your own beer as well?
I don't think he wants to come on now. I think it's for the party. What have you done, Rich? Costa will come. Costa's in the chat room. Everybody knows I met Costa a couple of weekends ago, and we went to Silbury Hill. And we also picked up a funny anomaly, which isn't maybe to other people like enslaved by no media, but we were standing at the car park and we were going like, God, look at the size of the pyramid, you know, Silbury Hill from here. But what it is there's these people standing at a fence. When you get to the fence, there's now a field in front of you and the pyramid's over there. But at the car park, it looks like the pyramid's up against the fence. So it was about, I don't know, maybe quarter of a mile, maybe a bit less than that. But standing there, we were all going, look at the size of it from here. So there's strange things that go on.
We've got one in Rochdale like that called Knoll Hill that looks like the bottom of a pyramid. It sticks out in the middle of the hills like it's man-made. It's got to be. And I've been up there digging about, and you can find blocks where a building used to be. And they say that nothing was ever there. But I can see all these big, massive sandstone blocks with shapes in them and everything. And it's like a Silbury Hill. It's quite big. And it does look bigger the further away you are. So, there's a lot of strange things we don't know about.
Yes, well, like I say, you can go to the Pyramid of the World on the internet and you'll find Silbury Hill in there. But you try telling anybody around here that that's a pyramid. They're just like, what? What do you mean? It's just, how can that be? It's in the pyramid of the world, yet the people who live here don't know it is. Yeah. Is that what? Would you like to say anything else then, Chris?
Like I said on my video, we need
Rich,
to work together.
Did you want to hear a bit more about Chris's first part then? Is that what you like? The bit about how far the stars were away, like his first video?
No, I see where he's going with this, and I'd like more details with exact. I'm thinking Orion's belt, because that's supposedly seen from all places on the Earth.
Any group of stars we'd have to agree what group of stars to photograph, and we both do it, and then we can compare the images. If we've got different cameras, I don't know how it would work through a set field of view. I've no idea. So we could work something out, even using a phone camera for a set field of view. You can set that up to take a picture of the stars, just to get an idea how this is going to work.
Now, just to get it right in my mind, you want to see if there's a difference with your altitude at the same longitude, and also longitudinal differences also.
Well, yeah, you could do both. But I think it just positions first, and you could work on altitude. But you could do that yourself, couldn't you? You could do that with altitude of the same group of stars through a set field of view and see if there's any change.
Yeah, and like you said, you could do that with any camera.
Yeah. So yeah, if we're referencing each other's work, then we've got to have a set field of view. But if you're doing it all yourself, you can set your own and do your own experiments. If we're working together, we need a set one for everybody. So the idea is get these P900s doing experiments all around the world, setting a reference for everyone to take images, to just go, right, bang, 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 bang. And we start showing this evidence, people are going to start taking notice. The ball guys are going to start taking notice and do their experiments, which I think they already are. So yeah, because this field of view, the video got a lot of interest off a lot of clever people, and I was having some really in-depth conversations with them, separate off the group chat. So yeah, it's things are happening, but it's just very quiet. But we need to work together. That's the only way we're going to get anywhere.
Yeah, I guess we need to set a certain date too. Or do you think that matters?
Pardon?
Do you think the time of year matters, or just any time you can see whatever group of stars everybody agrees on?
I don't think it matters. If you're photographing the same group of stars, if a couple of days, don't think it makes much difference. It's where you are and where the stars are. No, ideally, at the same time, take the photograph. But if you're doing it by yourself, it doesn't matter so much.
I'm so sorry to interrupt you, Chris.
It's fine.
I would suggest if we all took the same constellation at the same time, let's say we all focus on the Big Dipper. If you can see it, focus on the Big Dipper for, I don't know, 2 weeks, 14 days only, or 15, 16 days. And we all start Monday, and we take a picture of the Big Dipper from whatever. We're all seeing it from our perspective, but then we have to have obviously our orientation. I'm facing east, I'm facing west, I'm facing north, I'm facing whatever, you know. That way we can correlate and put them together. I mean, I can make a program on a computer doing that, man.
Well, the easiest setting I've got is to take photographs with the dusk to dawn setting on a P900 and just switch it on. Don't zoom it, just autofocus it and take the photograph. But I don't know if that image is good enough to gauge what we need. That's why I need to take some more photographs of it. So just put it on to dusk to dawn setting, take the photograph, no zoom, nothing, and just take that image. But I don't know if that's good enough for what we need. Because I've only done it once, so I need to do it a few times to check it works.
So your main goal is to see if the stars are close or far away.
Yeah. So yeah, That's
Okay.
basically it. Yeah.
Now, does anybody on the panel here or in the chat know what geocentrists believe as far as and I keep asking this question, how far away are the stars in the geocentric view of the universe? You know, where what was the name of that video that came, or that movie, that all the scientists came out and they were geocentrists. They think the Earth is a ball, and then we sit still, but everything rotates around us. They were using Tycho Brahe and a couple of things, but their theory is that we are a ball. I don't know why they want to stick with that, because so many things fall apart as soon as you get the water, and that the stars go around us. My question is, how far away are the stars? Because for two reasons. One, they have to go faster than the speed of light if they're millions of light years away, and they come back to the exact same location in a 24-hour period, then they're moving much faster than the speed of light. And they also all have to be the same distance away, because they all come back at the exact same time. So that would put, I guess, all the stars on a fixed globe outside of us that rotates around. But again, if they're saying, and I believe they think the stars are still the same distance that mainstream science says. So if you got a star that's 100 million light years away, and it goes all the way around from our perspective, since we're not moving, and comes back, within 4 minutes of 24 hours to the exact same position, then it's got to be moving hundreds of times the speed of light, if that makes sense to anybody. It's just the sheer distance away, having to go in that circular,
Hey, Rich,
the
do you
radius.
do you remember Owen from Australia? Do you remember that he came on a hangout? This is probably about a year ago. And he showed that he could, by driving, he could keep up with the stars. And then he made that thing that he sat in, and he moved it, and he took pictures and things. And basically the stars aren't going, he could keep up with the stars in a car.
So traveling, I guess, east or west at a certain speed, he could keep the stars in the same spot in the sky all night.
Yeah.
He made his own little experiment with, was it Aries failure he was trying to replicate, I do believe. But yeah, it was good. It was good.
Speaking of Aries failure, the question has come up, and people, of course, they keep trying to destroy it and say he wasn't actually trying to determine if the Earth was moving or not. And if you actually read, because it's available, if you read his white paper on it, what we would call it today, that's exactly what he was trying to figure out, was if the Earth was moving or not. So just for anybody that may have heard the rumors that that's not what Airy was actually going for, that is exactly what he was going for.
Yes. Also, I have put on the Sun and Moon, or mirrored, that high altitude balloon at night, and they say that the balloon is 17 miles up, and I can see the stars, some of the stars below the camera. So they're about, 14, 15 miles up. I think it's a bit of a shock because, first of all, there's flat Earth, and you start off with everything is millions of miles away, and then it's hundreds or thousands, hundreds, but it's not.
No, it's not.
And
Can
then
I share?
you know the bit with the star, like they see the star and they say, look, we can see stars through the moon. I think you're seeing the stars in front of the black disc. The moon. They're actually in front of the moon, not behind the moon. That's why you can see them. But anyway, sorry, Rich, carry on.
Oh, it's okay. Can I share my screen and show you what I just found out? It's going to be coming up in a video near you soon. So this is a preview of something amazing, I think.
Yeah, and I know that you can share okay as well, Rich, because we were on a hangout last night, and the last person that came on, Boogeyman, he showed the link.
No, that's not good. All right,
it's just happening.
All right, so let me set my screen up first. Okay, am I sharing?
Yeah.
Okay. Just to show you this picture here, isn't it amazing how all of a sudden, all the pictures of the Earth now, on the dark side, there's lights, whereas no lights ever showed up before about a year and a half ago on any kind of space imaging, supposedly. But now all the lights are there. Just as a side note. But the only reason why I'm showing this here is, and we talked about this a few minutes before we came live, me and Chris were talking about it. There is no way to light up more than half of a ball at any given time with one light source. We have one light source, which is the sun. We have a ball, which is the earth, supposedly. And this just depiction here, you cannot light up more than 50% of the earth at any given time. I don't care how you tilt it. Only half of the earth can ever be lit if you have one light source, which is the sun, correct? I think we all agree on that. So with, what's that?
If it's a ball, yeah, that's correct.
Yeah, if it's a ball, 50-50, there's no way to do it. Now, let me show you something. This goes back to our hangout with the other day where we were talking about the Lunalemma and things like that. And where I haven't even gotten to the point yet where he was showing us how when the moon is north of the equator and south of the equator, you can see it for more than 24 hours. I mean, for more than 12 hours at a time from both locations. That's an anomaly too. That's just blows away the ball. But this is, you know, lately I did a video showing that we were told that the equinox date, which is September 22nd this year, the sun, the daylight and evening hours, or the light and dark hours. I'm sorry, I'm not speaking too well today. It's early for me today. I had a rough night. But anyway, they are the same. And, you know, of course, I got the arguments. Well, the sun, yes, technically is over the equator on the equinox date, but it doesn't mean you're going to have equal times of light and dark. Well, why not? That makes no sense to me. But that led me to do some research on, and anybody can go here and do this, suncalc.org. And I've picked September 22nd as the date here. I don't know if you can see it or not. Now let me switch here to this and zoom in, because I've taken 5 screenshots and they're all based on September 22nd. I can blow this up a little bit more here. September 22nd, 2018. And the first shot here, let me, I don't want to show this first because let me show you the equator on this day. They're actually correct. Okay, here's just north of Quito, Ecuador. Let me zoom in a little bit here. There we go. Now, if I take the different times on Sun and Calc, the sun will go on this day straight across the equator. There's no variance north and south. It goes straight across this line, which is what you would expect on the equinox date. So the orientation of the Earth in relation to the sun is it's perpendicular on this date. So the North Pole, the South Pole, they're all straight up and down in regards to the sun on this date. I don't think anybody argues that. I hope not. That's the way it is. That's what science says anyway. But if you go back over here now on this date, when it's exactly splitting the Earth and the hemispheres in two, look at this right here. We have a daylight duration of 12 hours and 6 minutes, just shy, 2 seconds shy of 12 hours and 7 minutes. So even on the equator, when the Earth is perfectly aligned with the sun, and of course we have at 93 million miles, we have, you know, almost perfect perpendicular rays, 89.996 degrees is the actual number mathematically. So there is no way at the equator you would have more than 12 hours of day and night. It should be 12 hours precisely. And some people say, well, maybe, you know, it's not, it didn't precisely come at 12 noon, whatever. Okay. But it's not going to be 7 minutes off. So what people will say is, let me go back to my other picture here. This right here. What they'll, now this is exactly the way, if you're looking from the sun, the way the Earth is oriented on the equinox date. The sun is right over top where, I don't know if you can see my cursor, right in the middle of the ball, and the line is straight up and down. Now, we've all seen, like in the middle of winter in the northern hemisphere, or in the middle of winter in the southern hemisphere, let me rephrase that again. In December, the shadow will be actually off like this, and I'm exaggerating, but it'll show that the entire South Pole was in 24 hours of light. And in June, July, the orientation is the other way, where the spin of the Earth doesn't matter to the pole as long as you're above 66 degrees north, amazing number there, then you will see the sun all day long. But on the equinox date, it's straight up and down. So there should be exactly 12 hours a day and night. Now people will say, well, go north, Rich, you'll find that maybe it's a little bit less, it'll be like 11 hours and whatever up there, but a little bit more than south. Because they'll come up with this BS that there's refraction and all kind of different BS that affects it a little bit. But one side, like in the winter, one side will have more daylight than the other. Well, let's take a look at that. This amazed me when I look at when I actually got the results here. So let me back this out. So you just saw across the equator, we have almost 12 hours and 7 minutes of daylight, which it should be 12 hours exactly. Maybe a few seconds different because it didn't exactly cross at noon or whatever. But let's look at the next picture, which I think is the first one actually over here. All right, I went down here to Argentina, pretty far south, and even later on I went even further south than this just to see. You can see the sun path here is way to the north all day long, and then it comes back down to due east and due west, sunrise and sunset, which is another issue, which I won't cover here. But let's look at this over here. What do we have? We have daylight duration, 12 hours, 8 minutes, 20 seconds. So it's almost exactly the same as the equator. So we can say that south of the equator, and the equator is up here towards the top of the screen here. You can see the dashed line hopefully going across here. We have actually 12 hours, 8 minutes here. So that means at the same location north of the equator, we should have 11 hours and 52 minutes roughly up there. If it's not an exact thing, it's got to be a mirror image. It just has to be if it's a ball. So let's go to the north. And here we are in Cuba. And you can see here the sun rises due east on the equinox, comes down here, within a degree, whatever, comes down to the south all day, then comes back to due west at sunset, just like everybody experiences on that date. And what do we have here? We should have 11 hours and something. Daylight duration, 12 hours, 7 minutes, 57 seconds. Almost the exact same time as the south. So it doesn't matter if you go north or south. On this date, you have more than 12 hours of daylight, which is impossible on a ball. Now, let's take more extremes. Let's go down here. I took one more. This is all the way at the tip of South Africa. And here the sun actually rose well north of due east. Well, what it is it's not capturing all of it here. But anyway, it comes around way to the north, sets at due west. Well, what's our time here? Daylight duration, 12 hours, 7 minutes, 2 seconds. So no matter where you are on the earth, and I think the last one I did, let me see if I have it. Well, I don't have it here, but I can drag this up right now. Go way farther north. Let's come up here to Sweden. Still September 22nd. Daylight duration, 12 hours, 20 minutes. So no matter where you are on the earth, north and south, I'll stop sharing here, you have more than 12 hours of daylight. And that is impossible. It just is absolutely impossible. So any thoughts or anything on that? I don't know. It's just, to me, it makes no sense. And it's another ball buster.
Well, that's exactly what we need to rip into. Like you say, Rich, it's impossible. And if it's impossible, we need to say, this is what's really happening. Now, if you take a photo, series of photos from your location, Chris does the same, and numerous other people do the same from their locations, We can figure this out, and we can do another like time and date, you know, but where we trust what we see and trust what we're recording, and we understand exactly what it is we're photographing, you know.
Can I say something as well? You know, I have in the past and recently watched quite a lot of Enslaved by No Media, and all he seems to be finding out is that they're lying about the distances, and he doesn't think that where we live is as big as they say it is. So that's like, maybe that's something to do with why nothing adds up, why you're seeing the 12 hours everywhere, because we're not as big as they say we are.
Well, it definitely can't be the model that they're giving us, because you can't have more than half the ball lit at the same time with their model. It's just impossible.
Yeah, all the disproving of that stupid ball that never even existed.
I don't know because I don't know how many people touch this subject, but I keep getting, you know, what busts the flat earth is the fact that on the equinox date, if you look due east, no matter where you are, you see the sunrise, 090 degrees, and due west, 270 degrees, you see sunset on that date. Well, think about it. If you're on a ball and you're way up here and you have to look down to the equator, how are you seeing it due east on a ball? Or down here, it busts both models. It really does. The azimuthal equatorial doesn't work with that, and neither does the ball. There is an answer to the problem, and the answer is we do not see the sun directly. We see a reflection of the sun. And that's also, I think, what explains how we can have more than 12 hours of daylight on a ball from one light source, because we're seeing a reflection of the sun. And it's not a flat reflection, it's a parabolic type of reflection. And that explains it. Explains if you assume that the sun is not being seen directly by us, we're seeing a projection of the sun only. So many things make sense, from rainbows to daylight hours. Everything just seems to make sense. And then you'll have people argue, and I haven't busted anybody on this yet, but they'll say, yeah, but some places on the globe, it'll be 2 degrees off or 1 degree off of due east or west. So that allows for the ball. Well, there is a rule in physics called the 160 rule, whereas for every degree that you are off, what is it? Every 60 miles, you're 1 mile off.
Is it just me, or is it Rich breaking up?
Am I breaking up?
It's you, Astral.
Sorry, Rich. Is it just me, or are you?
It's you, Astral.
Everybody.
It's you.
It's you, Astral.
It's you.
I can't hear anything. Sorry, I'm going.
Let me read
Rich,
you. Go ahead.
Rich, Super Clever Turk's videos, he talks about the sun revolving in a figure of 8, and one side's a reflection of the sun and one's the actual sun. So look at his video.
Yeah, I've actually dropped that link in the chat for other people to see, to go to his channel.
I've just put the link in.
Oh, awesome.
Yeah.
Yeah, I haven't seen his videos, but just looking at the titles and the thumbnails, they look fantastic.
That would make sense to why sometimes we see the black disk moon and sometimes why we don't.
Yeah, he's saying something in the figure of 8. On one side, it moves around. He shows all the seasons, the months, the years. He's got it worked out on that model. I think it's absolutely brilliant what he's done. It's well worth a look. And he's not had many views at all on the groundbreaking stuff he's put out. But, yeah. He might be worth getting on, but I don't think his English is the brilliant, but he'd have some interesting points to put through. Have a look at his stuff, Karen.
What's his language?
Turk. Super Clever Turk.
What's his name again? Sorry, what's his name again?
I don't know his real name. It's called Super Clever Turk. I've dropped a link in the chat. So I can drop it again if you need, or I can text you the link, Karen.
Oh, yes. Say it again. Super what?
Super Clever, one word, and then Turk.
Turk.
I still didn't hear it. My computer.
I'll type it in.
Okay, thank you. All right, okay. Thank you.
In navigation, there's what's called a 1 in 60 rule, and I'll just read it here. In air navigation, and it's any navigation, in the 160 rule is a rule of thumb which states that if a pilot has traveled 60 miles, then an error in track of 1 mile is approximately a 1 degree error in heading, and proportionally more for larger errors. So what that boiling that down means is that if you're 1 degree off in your heading, just 1 degree, and this works for anybody that's on the ground, you're lost and you're trying to travel back somewhere, why compasses aren't going to be very good, because if you're even 1 degree off, you're going to be, for every 60 miles you have to walk, you're going to have a 1 mile error. So 1 degree off, 60 miles out, you're 1 mile off your target already. Now, if you take that and extrapolate it out to 93 million miles from the sun, and you say, okay, there's, it's 2 degrees, everybody on the earth, they're saying with a ball, you should see it at 090 degrees. Well, some places you see it at 092 degrees. So that's 2 degrees off. When you extrapolate it out, the error at that distance is double the width of the sun off. It's like 3 million or 30 million miles off, whatever. You do the math, and that blows away the ball too. If you're just 1 degree off at 93 million miles, it puts the sun so far off course from where it is. It's actually more off course than the width of that they tell us the sun is, which is huge. So no matter where they go with that argument, they lose unless you say the sun is a reflection. And I'm 100% convinced it is. This is why you can see clouds go behind the sun and in front of the sun. Or we've all seen that aircraft that was showing that the sun looked like it was totally below the clouds the whole time. That could have been an optical illusion. But there's just so many things that make sense with the sun if you assume that it is. In fact, I think it's an assumption to assume we see it directly with all the evidence. Like I said, from rainbows to sundogs to all kind of things. It's why we each have our own independent sun that we see. It's why a person 5 miles up the beach has their own beam of light going across the water that meets them at their feet, and you have your own beam. You have your own sun, and that's only possible if you're seeing behind a glass or a reflection. You're seeing a reflection of it. A reflection will follow you no matter where you go. So all those things, so many things make sense if you say we don't see the sun directly. And like I said, if you say we see the sun directly, then observations on the equinox dates make no sense either on the azimuthal, equatorial, or on the ball. They make no sense on either model.
Robert Forsch had this video that it bugged me, but again, maybe I'm just dim or something. But he was filming this pool of water, and the sun hadn't come yet. The sun was sort of a bit on the horizon coming across, and yet from his camera the pool of water could see the sun in the reflection, but the sun wasn't there, was it? It's behind the pool of water, and yet in that water it still picked up the sun. I was like, that bugged me. And he also had this, he did it upside down, but he did this dog, and then suddenly the dog walks and then the whole thing flicks round, but you can't see the flick. It just does it in the footage. They're on Sun and Moon, but I'll try and get those to you, Rich, because they're just amazing.
Yeah, that sounds amazing.
You don't see the dog flip round, but it does. You can't just pick one frame and think, oh, right, now it's turning and see it. It's just 1 minute it's going that way and then it flicks around. I know that sounds it doesn't sound, I'll have to send it to you, Rich.
Alrighty, I look forward to it. Hey, Chris, how can we help to get your project moving? Should we set a certain date or time or ask for volunteers first? I guess maybe that's the first step.
You just muted yourself.
I think I need to get some advice on the cameras, or I can just wing it and trial and error it. Give me a couple of weeks to do that. I need some stars in the sky to get it all sorted out.
Okay.
You 2 weeks to get that sorted out. Hopefully I'll have some clear skies by then. if I get it before, I can let Cameron know, and then we can get together and chat about best way forward to do what we're doing. Unless
Okay.
someone's got better ideas on how to get set field of view, set way for everyone to take photographs with a P900.
Okay. All right. So we'll wait for you to get the camera information. Hopefully you can find somebody that's an expert in cameras or whatever. But yeah, when you're ready to go, let me know. We'll, I'll put a shout out on my channel to see if we can get volunteers all over the world or whatever is needed.
Great. Yeah. So as soon as I can find out.
You could do, if you wanted to, Chris, you could, like, I don't mean use in a horrible way, but you could use Sun and Moon to maybe do the experiment and try and get the people at the same time and try to get people more involved that way.
That's exactly what I was thinking. Yeah. Well, I'm just trying to get this set field of view, whatever way we do it, sorted out first, and how to take a picture. And then I can.
Like you can be maybe on a hangout while it's all happening.
Yeah, just demonstrating as we're doing it. So yeah, it's making it as simple as possible. That's the hardest bit, to try and make it so everyone can do it. So that's what I'm trying to do.
Do you know if the ability exists? Do you know if the ability exists to have a P900 sort of live stream with it seeing?
No, it won't connect to a monitor direct.
Okay.
I've tried it. It won't do it.
Because that would be cool to get two people, two different locations to at the same time, split screen and see what they're showing.
You can with the P1000 because it's got a new HDMI socket on it, and you can connect it straight to a TV.
Hello, Dave.
How you doing? All right.
I was just going to wait for that moment to introduce you, but you've done it. Anyway, carry on. We'll keep talking, guys.
Yeah, nice to be here anyway. Nice to see you all.
Hey,
How you doing, Chris? All right.
I'm fine, mate.
Dave?
Say again. Sorry, Rich.
Did you get the word we can work together in Colorado?
Yes. Thanks. I've been a little bit busy. I literally landed on Thursday morning, and I was at work straight away on Thursday morning as well. So it's been a bit of a mad one. This is the first time I've really had to had 5 minutes to sit down, so. Yes, but that was brilliant, mate. Yeah, and hopefully we can get some really good smashed out.
Yeah, what I'll do is I've got your email address. I will send you the different things I'm going to cover. It'll probably be something we continually update because I keep thinking of new things to put together in a presentation. Are you planning to do like a video presentation or a slideshow?
I was thinking more of a slideshow because that's what I built all my presentation around, you see. And what I can do, I can use sections of it if I want and just re-edit that section of the presentation if I want to make it shorter, or if I want a big long presentation, I could do the whole lot. But that'll probably take a long time. I'm thinking something short and sharp, maybe 30 minutes, something like that. I don't know what your thoughts on that.
Yeah, I think I can zip through a whole lot of stuff pretty quickly because there's no need to go into a lot of detail. If you want detail, we can give it after the presentation.
Yeah, like I say, it'd be good. I'm looking forward to it.
Well, we were talking, I don't know how much you heard before, but your talk about the equinox and your different SunCalc things got me going. And I did a video on because you were talking about how it's 5 days late this year when it's equal days and nights, which should be the equinox date. There's all kind of excuses why there's not now that people have chimed in. No, just because it's over the equator that day doesn't mean that's equal day and night. Well, it should be.
Yeah, the same refraction as well.
Yeah, but if you look at other years, it's off those years as well. But yeah, refraction. It's always refraction, and it's always in their favor. But what I just showed was that on September 22nd, what they say is the equinox date, there's an impossibility that happens, and that is no matter where you are on the Earth, you have more than 12 hours of daylight that day. It doesn't matter if you're up in Ireland. It doesn't matter if you're at the tip of South America or on the equator. It's all around 12 hours, 7 or 12 hours, 8 minutes of light on a ball, which is impossible from a light source.
Yep, exactly. Yes, and like I say, I did find out something. I was talking about the minor lunar standstill on the autumn equinox. Well, the same phenomena happens for the southern hemisphere on the spring equinox as well. So you get that, what I call a lunar jump around the spring equinox as well, but from the southern side. So obviously when the moon's like jumping south, you get that same phenomena that we've actually just had on the autumn equinox. So that's interesting. I went to my favorite place in the south, Ushuaia, and I had a look at the readings from there. And yes, again, it's doing that big jump, and the moon's rising less than 20 minutes every day over that short period over the spring equinox. So that's interesting. Doesn't look very good for the circle model though, but it looks pretty good for the lunar lemur. That is a cert.
Yeah. You mean the AE model? Is that what you're talking about?
Yes, it like I say, with that moon jumping and rising 20 minutes earlier south of the observer, it's going to be a little bit tricky to get it to work on that model when you should be looking north to the Tropic of Capricorn from southern Argentina.
Can I add something there, by the way? Because we had obviously Stan and Crow 777 on last night. And then suddenly, in the middle of it all, he started saying that actually he favours probably the square flat Earth map now. It's the only one that kind of works that he can see. So I just thought I'd tell you that it's the only one that the other ones don't work for him, but that he's actually coming round to the square flat map now.
Who's that? Who's that said that?
Crow 777.
Crow. Okay.
What I would say, and I've said it numerous times now, that regardless of whatever model you're looking at, it always needs that supernatural phenomenon to work. Whether it's a globe and it needs some kind of magical force to all that water on, yeah, the square model needs some kind of supernatural portals to take it from one side to the other. You know what I mean? They've all got these little. Every single model has its problem, and to me, it looks like no geometry, maths, or whatever can get it to work perfect. That's why we're finding all these little inconsistencies with the globe model, because it just will not work through math, science, and geometry. You know what I mean? There is some kind of supernatural phenomena taking place. What that is, I don't know, but I believe that something is happening, in regards to the luminaries, especially like the sun and the moon. Things are happening what just can't be explained. Yeah,
well, I don't think we see any of them directly, personally.
Well, I've said that from probably for the last 2 years now, that what we're probably seeing in the sky is probably projected images. What they're projected from, I don't know, but what we're seeing from Earth when we look up and we see that moon lighting them clouds up locally, is not an image. You know what I mean? It's just a projected image. So that's my take on that, and I've stuck to my guns on that. And the more I research it, and the more it seems more possible.
Yeah, that's what I definitely think it is. There's so many anomalies there too. You have all those craters, but you have no boulders. They're all supposedly came straight down because there's no trails this way.
Exactly. So they'd have to hit perpendicular with a globe blocking it. So they'd have to do like a swerve around, dodge the gravity, and then come down perpendicular to the moon and make perfectly round circles, which...
Yeah, simple observation tells you that what they've told us is wrong. And then you have the outies, like the any belly buttons, you have the outie belly buttons. You have some craters that are actually raised in the center, a little bump, as if something tried to come from below.
Yeah, I've got a good shot of that. It's weird. It's like a little hexagonal kind of a shaped lump, but it looks like it sticks out quite a lot. It's quite interesting that, when you change the contrast on the image, it really stands out that as well. You know what I mean? You can really make that like lump stand out a little bit. So that's interesting. And like I mentioned before about during a lunar eclipse, when you get a 100% moon for nearly 9 hours, and how would that work on a globe? You know what I mean?
Yeah, and how do you get a total eclipse when it's not 100% opposite of the sun, which is what happened last August?
I thought something might have happened on the 25th, actually, because they were both aligned with the apparent ecliptic of the Earth. And, you know what I mean? I filmed the full moon from rise right through till zenith, right through till about 4:30 in the morning.
Oh, that's right. You were looking for that. I forgot about that.
Yeah, I filmed it. I didn't see anything out of the ordinary. I was actually in Fuerteventura. The skies there are perfect for shooting the sun and moon. Unbelievable. Not a cloud in the sky, day or night, or a chemtrail for a full week. It was brilliant.
Where was that again?
Fuerteventura. It's just off the coast of Africa. It's the Canary Islands. Yeah, okay. It's 28 degrees north. It's quite just above the Tropic of Cancer, a fraction above.
Well, going along with what we've been talking about, there's so many people trying to determine either a map or whatever, how things work by using the sun and taking angles from where they are, how high the sun is. To me, it's just
Impossible.
foolishness because you're not seeing it directly. So they're always going to be led in circles, I think, without a conclusion.
Yeah, and like I say, when people like in southern Argentina on their summer solstice are seeing the moon, the sun and the moon rise south of them, and it's visible for 17 and a half hours, and it's setting south of them. Yeah, there's no answer to that on a circle model. It just can't be answered. You know what I mean? We know there's no measurable curvature. We know it's definitely not a globe, but it doesn't fit the circle model either. And that's even if you take into account the 13.5 degrees magnetic declination. Even if you took that into consideration, it's still rising south of the observer. You know what I mean? So it's.
Dave, did you say 17 and a half hours of sunlight?
Yes, if you go to Ushuaia on December the 21st, which is their summer solstice, what you'll see, they have the exact same daylight hours as 55 degrees north, somewhere probably up in Scotland.
Okay, what would be the opposite side of that location, and how much sunlight did they get?
Same as in Scotland. If you go to Scotland, yeah. Well, if you went to Scotland. Go on.
I think what he's saying is if you got 17 and a half hours there, at some location you should only have 24 hours minus 17 and a half. Is that right, Astral? Five and a half hours. Somewhere should only have the exact opposite.
Yeah, exactly. If they've got 10 hours here, then they have to have an equivalent will lead up to 24 or 12 hours somewhere else, It has to equalize. There has to be a balance. Certainly, you can't have too much, like 3/4 and only a quarter here, can you? You have to have a balance. It has to be equal, either or, up or down, a little bit, a little less. Do you understand what I'm saying?
I think what you're. Yeah.
Well,
So
obviously on December the
21st.
On December 21st, we only get what is it, 5 or 6 hours daylight, is it? You know what I mean? So we are getting the opposite effect from that southern latitude in the northern hemisphere, just like on our summer solstice, they're getting the opposite effect on theirs. If you went on to SunCalc and you put June 21st, June 22nd in the UK, then you dragged it down to Ushuaia on the same day, you probably see it's like the opposite. You know what I mean? We're getting all the daylight and a little bit of night, whereas they're getting all the night and a little bit of daylight. So I would think it would equal itself out.
Well, it certainly didn't on the equinox. It certainly didn't equal out. There's no place on the Earth I can find that has less than 12 hours of light.
It's crazy.
But there are lots of places, don't they? Like from the summer to the winter, they only get a couple of hours difference. Australia, places in America. So say, I'm not saying this is the exact time, but just say it gets dark at 6 o'clock in the winter. It stays light till 8 o'clock. But we don't get that. We get a massive swing, not maybe as much as if you're norther or like at the top of Greenland or something, but we go 6 hours of light to about 18 hours of light.
Yes, because we get what you call twilight. A lot of places near around the equator, they don't get the twilight, you see. It's literally light and dark there, where we get like twilight, you know what I mean? We get some like quite long nights where it's not quite dark and it takes a long time for it to go dark. In fact, on the summer solstice, the sky's like a dark blue. It doesn't really go dark in the UK, so.
So like 3 a.m. it's still 2 a.m. still blue.
It's like a dark blue. Yeah, it's not pitch black like it is now. If you go outside now, it's pitch black. You know what I mean? You can't see anything like outside apart from the moon and the stars. But yeah, like on the summer solstice, if you look out your window at 3 in the morning, you'll be like a dark blue.
And yet no matter how bright the moon is, you never see any blue around it.
Nope.
That's one thing I want to cover at the conference.
There's something else that happens as well. Some places, like, it could take about an hour for it to get dark here, but some places, the moment it starts getting dark, a couple of minutes later, it's dark.
It does in Fuerteventura. I couldn't believe it when obviously because I've been looking at the sky a lot, and that's the furthest I've been towards the equator since I've been looking into flat Earth, and just to see how fast it goes dark there. Once that sunset, it's like bang, it's dark in like about 30 minutes. It's crazy. Whereas here, you know what I mean, when the sun goes down, it's like it's another 2 hours before it goes dark. But I was looking at the moon rising times around the equinox, and it rises an hour early in the UK, even though we're on the same time zone in Fuerteventura as the UK, exact same time zone. I didn't have to change my watch when I was there. It was the same time.
Well, yeah, because it runs down Portugal to Africa, doesn't it?
Yeah, just run straight down.
Can I also say that's what I don't understand. Like, we've got this curve of the Earth, and this, like, us in the UK or in the Northern Hemisphere, right? But yeah, you can be down. You can be. I mean, yeah, Azores. What are they? Are they on the same time zone as us? And they're close to the equator, aren't they?
Yeah, but they're on the same meridian line. That's the problem. That's why, because they're basically within that the meridian time. You know what I mean? It runs parallel down, and obviously we fall in that. There probably is a time difference, because I do think they're actually a little bit further west than the UK, but it still falls into that time zone. But yeah, it was strange, like there, with it being the same time and that, because they get a lot less daylight there, even though you're closer to the sun. Yeah, and the moonlight rises really fast, and it sets really fast there as well. It's like it's gone in like an hour. You look up, it's there, then you look up again, and it's gone. Whereas we get that arc, you see, it's like a straight line there. It's like a big wheel. It comes straight over your head, and it's gone. That's it. It's just straight over, and the sun is the same, straight over. All the stars straight over you. Yeah, there's no arc there.
Bed, please, brother, when you lay in bed tonight, right? Think about exactly what you've just said then. Why could that be? You're close to the equator, it gets dark early. Think about that, man.
Yeah, I know. You get access to less daylight the closer you get to the equator. Whereas there you get like equal, it's like an equilibrium, isn't it? You know what I mean? They get the sun visible for 12 hours, probably a little bit more. But whereas we in the UK, we'll see the sun for 17 hours.
I have to say this though, that I do really believe that we are tilted on our side though, that we're not straight up like the map shows. We're on a bit of an angle. Even Devon gets darker earlier than I do. And that proves then that we must be on an angle.
Yeah, it's strange, because the further north you go, the access to more daylight you get. Obviously, you get up to 78 degrees in Svalbard, and you're starting to see the 24-hour sun for 5 or 6 months. You know what I mean? So,
see, I think noticing those differences, we could eventually figure out the parabolic shape of whatever it is in front of the real sun that gives us its reflection.
Yeah, like I say, I ain't even really touched on the sun, although I've been doing making some observations. I've been doing a moon style race with the sun called, we're just naming it Soul Crossing for the time being, where I shot the moon on the Tropic of Capricorn. I've just shot it on the equinox. I'll be shooting it again on the winter solstice, and then on obviously the March equinox as well, to see and just taking as much information you've got. I've got rise times, set times, the time it takes the sun to transverse over 12 hours. I've got the azimuth, I've got the solar noon time, I've got the meridian passing time in hours and minutes. I've got all this information here, what I'm going to pump into the video. And then obviously when I repeat the video, which I've just done now, and I build a video, then I can start comparing the data. At the moment, I've only got one lot of data, and I can't really compare it with anything. But as the data comes in and I start getting more and more data, then I'm hopefully able to start seeing like either a pattern or things. Like I said, when I did my moon race video, I didn't know what I was looking for. You know what I mean? I just did it, and like I say, it just built up and built up and built up, and as you look into the data more and more and more, things just seem to pop out of you. So if you look at the graph I produced with the moon over a year, and you see that light heartbeat, and you see that same pattern where it speeds up at the exact same point every time.
That's what I saw. I've told you I saw the moon dragging the stars. It came in and did like this heartbeat thing. I told Dave about that. Dave, can I ask you just something as you're there? I know got a lot on your plate, because you've told me. But Chris is here, right? And Chris, are you there, Chris? Chris?
Yes, I'm here, Karen.
As Dave's here and he's a cameraman, can you just explain a bit your, like, tiny bit of how maybe he can say something to you about your field of view thing?
Have I mentioned about the field of view today?
I don't think you have, mate.
Right, I'm trying to get a set field of view through basically taking a photograph through a frame or using a camera. Yeah, just so from 2 points, take a photograph of a group of stars and compare how they fill the field of view. And I'm trying to get the best settings on a P900 to do that, and the best way to take a photograph of a field
Which
of
view. would be at 2000 millimeter. I would recommend to optical zoom, because what you could do then, you could both set your camera to optical 2000 millimeter equivalent to 35 millimeter, and you could all shoot it at that. I've done the similar thing with my Sun experiment, where I'm shooting at, even though we've got different cameras, Jenna's shooting hers at 1400 millimeter optical zoom, and I'm shooting mine at 1440 millimeter optical zoom. Although we can't match because we've got different cameras, but you can use, you can actually, if you want to set it a zoom further away, you'll have to just count the clicks on the camera. And what you can do, you can open the image up with a forensic photo or something like that, and it will tell you the millimeter equivalent on the camera. So say if you zoom in 5 clicks outwards, because it doesn't tell you on the camera what you're actually zoomed at, but when you look at the image through photo forensics, you can have a look at the actual equivalent in 35 millimeter zoom.
So Rich could take a photograph of a group of stars where he is, and I could.
Yes, and what you could do, and then you can make sure you're on the same zoom, because when you take a test shot, you can quickly send that image to your phone, because if you use a Wi-Fi app or SnapBridge, you can send it to your phone, and you can open that image up straight away in photo forensics, click on the metadata, and it'll tell you everything you need to know about that image, and then you can compare the actual images on your actual phone with the data you've got. That makes sense.
Some of it, yeah, I was going to say some of it was a bit Welsh to me.
Basically, a photo contains all the metadata. Yeah. So when you're zooming in with the camera, when you're at half zoom, you don't know what that zoom is on the camera. It doesn't tell you. It doesn't tell you it's a 20 times zoom or whatever. The only way you can find out is by taking a test shot, sending that image to your phone, going on to photo forensics, open it up in metadata, and look at the actual file data on the phone, on the actual image, and you'll see what camera you used, what zoom you was at, what equivalent in 35 millimeter. So you can actually compare all the data, and that's what I've done with Jenna. We've actually matched up the zooms on our cameras, even though we're using completely different cameras. I'm using a Nikon Coolpix B700, whereas she's using a P900. It'd be nice to use 2 P900s. I just don't have that luxury. So, but we are comparing it same, and you have to count the clicks on the camera. You have to put it to optical zoom, then you have to click it back about 5 or 6 times, depending on what zoom you want.
I'm after just everyone using P900s to just do this, basically. Get this mass of people with P900s out doing experiments and doing it as simple as possible.
Yeah, like I say, it depends. Are you talking about doing star trails or just doing still shots of the actual stars?
Still shots, but I'm after setting a set field of view. And what you're telling me, yeah, it makes sense to me. I could do that, but for most people, it wouldn't do. It's not that simple. So I'm trying to make it as simple as possible.
Yeah. Well, what you could do,
yeah,
you could just shoot it at the set zoom the camera when you switch it on, and then what you could do, you could get them to email you all the images, and you could get somebody to compile all the metadata from each image. You know, just to make sure you've got the right settings for the right camera. You know what I mean? Say if you just put it to moon set, everybody puts it to moon setting, doesn't touch anything else, just autofocus and take a shot, then you should all have the same settings and the same zoom, and you can always compare that data, get somebody to compile it all. It takes about 30 seconds to get the metadata from an image.
Right, yeah, that was one of my ideas, just set it off default photograph.
Off default, yeah.
Yeah, and away you go. Yeah, that could be a good way to go, because I'm trying all these ways out, but we need clear skies. We've not had clear skies for a few weeks.
It's a nightmare, I tell you. Like I say, I've been trying to shoot the moon at apogee now since what, May? I just can't do it. It just haven't had the weather for it, and the moon's been in the wrong position. It's either been daytime or it's either been cloudy. You know what I mean? My next opportunity is actually 31st of October to actually catch the moon at perigee. I've actually got it at 3 times at apogee now. Yeah, that's brilliant. Yeah, but I want to get it at perigee now. So hopefully on 31st of October, it'll be in the right position and it'll be dark. And I'll be able to have a decent sized moon to measure, because I need to measure the moon as well, you see. If it's a small little crescent moon, I can't really measure it. I need it to be at least half a moon, and it don't get half a moon till after October. So,
well, I've got a big one that you might be able to help with, Dave. I know I've talked to you about it before, about taking a photograph of the moon, the crescent moon with the sun behind me. So the moon's north, the sun's south, and I've seen it twice. But I didn't have a camera with me. I was wondering, is there a date or a time or a best place or best way to find out how to find it? When the best time would be?
A crescent moon is normally pretty close to the sun, normally.
Yeah, but well, I've seen not a crescent moon in the north or the south and the sun right directly behind me. I've seen it twice.
I've never seen it like that, because like I say, a crescent moon is normally close to the sun, whether it's a waning crescent or a waxing crescent. So, you know what I mean? It's a quarter distance way at first quarter. You know what I mean? Yeah. Then obviously when it's opposite, it's a full moon, and then you're back to 3/4 at the waning point, and then it's back to new moon again. So it would be very, very difficult to catch a crescent moon opposite the sun.
Right, yeah, because I pointed out to my son-in-law, his friends, and says, how can it be that be working like that? As I walked out of his shop, and he remembers me pointing out to him, and I've seen it before. But I'll just keep my eyes open. As soon as I see it, I'll just
keep your eyes open. Like I say, I mean, you could go through moon calc every day for as long as you want, like I said, but you'd have to click on each individual day. You know what I mean? So.
Yeah, well, I'll just keep an eye on what the moon's doing, and then I'll look where the sun is, and that's the way I've been doing it, waiting for it to happen. It's happened a bit, but not actually behind me.
Yeah. Yeah, cool.
Yeah. Right, thanks, Dave. I'll have a go at them shots when we get some clear nights.
Yeah, like I say, it's a good idea that to see what you're actually getting in your field of view.
Yeah,
I think the metadata idea is perfect. That'll prove everybody's got the same settings.
Yeah, and that's what I've been doing recently. Everything images I take now, I'm using the metadata to back up my images and obviously to verify them. Something NASA can't do. You know what I mean? I can verify every single one of my images because all the important images I've got, I've kept all the metadata for them, so we can actually compare. If somebody says to me, "That's not a real shot," want to bet? Yeah, have a look at the metadata, because there's the proof.
Is photo forensics the best tool to use?
It's quite simple. I use another one. I've got a measuring tool, what I used to measure the moon with, and if you click on the information, it gives you all the metadata on that as well. I prefer that because it does it in 16.9, so when you're presenting it looks all right. But the metadata from photo forensics, it's like in a long strip, if you know what I mean. It doesn't look very good on the screen. So I just prefer the other metadata for the simple reason, just for the look of it, because it obviously fills the screen out and it makes it look a little bit better when you're presenting things.
Right, great. That's great help, yeah.
When you talk, Dave, it's not just a case of taking a photograph. You should hear yourself sometimes. I mean, I know you can't say scientist and stuff quite like that, but like the effort and what you're talking about, it's amazing.
Well, like I say, all I'm doing is observing, measuring, and recording. You know what I mean? I'm just doing the basics, really. That's all I'm doing. I'm not doing anything fancy. I'm just doing the basic stuff: observing, measuring, and recording. That's all I'm doing. It's just a matter of how you document it. You know what I mean? So.
That's what scientists.
Yeah, true. But like I say, I don't class myself as a scientist. I never have, and I never will. You know what I mean? I'm just like a normal person, just like everybody else.
What we
But
need to
it
do
just
is we
means,
need to lock you, Chris, and Stan in the building for 6 months or something.
yeah, Stan. I mean, I wish I had the time he had to the amount of stuff he shoots. You know what I mean? I'm doing mine like semi-part time when I finish work or before I go to work. You know what I mean? I'm trying to squeeze it in here, there, and everywhere. But Stan, every time I look on YouTube, he's got a new video out. I wish I had the time to do that. That's why I loved it when I was on holiday. You know what I mean? I could get up early in the morning, shoot the sun, shoot the sunset, then shoot the moon rising. You know what I mean? I've got no end of photographs. And like I say, I did a couple of little experiments while I was there because the moon just happened to be at apogee. So what I did, I took the advantage and recorded it a bit like a moon ray style video and shot it at 40 millimeter so I can measure it with my apogee, what I've already got from this location here in the UK. And Jenna took a snapshot for me as well when it was at apogee from Buffalo, New York. So I've got 3 now. You know what I mean? So when the moon's at perigee next time, and it should get bigger according to Kepler's law, then I'll obviously, well, I'll be adding that to my presentation because even though I can verify my shots on the other one, I just wanted it to do this, you know, properly. This one little bit of experiment where I've got the moon at bang on apogee, not a day before or a day after, bang on. And what I did, I waited till it was at zenith as well on the day of apogee, so I'm getting it at its closest point to me. Because obviously, if I did it on rising, yeah, we know we get atmospheric lensing and the moon would appear bigger. So if I do it at a set point at zenith, 180 degrees south, then I'm trying to keep all my observations consistent from that point.
Hey, did anybody else notice that the moon yesterday was huge when it was rising?
Yes, it was today as well.
It's been huge for the last few days, and it's traveling. Okay, it's coming up east, but it's coming up more
it's
north.
Heading north. Yeah, it's heading north.
No, Karen, you're supposed to say it's coming past my window and going over my house, and it's like going over there.
Yeah,
going
it's
back.
because
the other way.
if you look at time and day, it's still doing quite big leaps, even though it's not quite 20 minutes now, rising 20 minutes earlier. It's like 23 or 4 minutes earlier, 25 minutes earlier. It's still doing huge leaps north, you know what I mean? And people are noticing it because it's there one day when it rises, next day it's over there when it rises. You're like, wow, how does it get from there to there? Because it's doing these huge leaps.
It did a bigger jump from last night.
Yes, and it'll do a few more, yeah.
Hey, Dave, when we were on last, you were talking about, I think it was when the moon was both on the Tropic of Capricorn and Cancer, when you were a certain part north, very north, that the moon was visible 24 hours. Is that correct?
Yes, it is. Yeah, and south. Yeah, it's if you go to Svalbard and you click on when the moon's high on the Tropic of Cancer, what you'll see is the moon's visible for 5 days straight from that location.
What's the location again?
Go to Svalbard.
How do you spell that?
It's Svalbard, Norway.
Okay, good.
Get some little islands.
It's that little island above Norway.
That's the one.
I've got an English friend here in Denmark who used to live there. He lived there for a few years, actually.
If you go to Moonkalk now the moon's getting towards the Tropic of Cancer, it'll probably be visible from now on Moonkalk for 24 hours. If not, just go forward a couple of days and you'll see it. It'll say circumpolar on the meridian passing.
But
and
if I remember,
that means dragging the stars again. Capricorn and Cancer, the moon pulls the stars.
well, if I remember right, Dave, it didn't matter if it was on Capricorn or Cancer. Both times from that location, you could see it 24 hours.
Yes, you can, but obviously when the moon gets southern declination, then it's not visible at all for about 5-6 days. You know what I mean? Then if you go to the same southern latitude, you'll see it's visible from their location 24 hours. And there's only like about 13 days in it. You know what I mean? Between the moon going from one tropic to the next tropic.
Right, but that should be impossible on the globe model. It's like being able to see the sun 24 hours. You can't see it if it's on both tropics. But
yes,
you can
I know.
with the moon.
You can with the moon because it crosses the equator 26 times a year compared to the sun, which only crosses it twice. That's why.
But you should never, from that Norway location, be able to see the moon 24 hours when it's over Capricorn. But you can. Is that correct?
No, you can't when it's over Capricorn. But if you go to the southern location, then you will see it 24 hours from that location when it's on the Tropic of Capricorn.
What about when it's over the equator?
When it's over the equator, it's only visible for a very short amount of time.
Dave, can I ask you, what happens with the moon up in the northern hemisphere in comparison to the southern hemisphere? In wintertime.
It doesn't matter what time of the year it is, yeah, because the moon's got its own cycle within that year. You know what I mean? So the moon will do its cycle regardless. Yeah. So whether the sun's low on the Tropic of Capricorn, the moon could be super high on the Tropic of Cancer, or the sun could be super high on the Tropic of Cancer, and the moon could be up there as well. But what you won't, the reason why I don't notice it is when they're both up there together, it's nearly a new moon or a very small crescent moon. You know what I mean?
Yeah, that moon is a tricky bugger, that is, because
like I say, the sun is like pretty stable if you track it. You know what I mean? It's quite stable throughout the year. You know what I mean? But then you look at the moon and it's here, there, and everywhere. You know what I mean? You've got the animalistic cycle, 29.5 days. You've got the apparent orbit of the moon, 27.3 days. You've got the synodal phases, which is 29.5 days. I think you've got about another 3 or 4 different kind of cycles within that. You know what I mean? The moon's doing all sorts of things, yet they work perfectly in harmony together, the sun and moon.
Yeah, and like, who was it who said the other day, it's the hare and the tortoise that's having a race, and it is.
Yeah, exactly. But thing is, although the sun does appear to move faster than the moon, when it comes to going from tropic to tropic, the moon's 26 times faster. You know what I mean? It's crossing 13 times faster. So it's crossing the equator 26 times a year compared to the sun, which we know only does it twice in 1 year, whereas the moon can go from tropic to tropic in 14 days.
So we should have loads and loads of lunar eclipses, shouldn't we?
We should do. Yeah, I mean, like I say, if you looked at where the sun and the moon were on the 25th, they were both apparently aligned with the ecliptic. So really, in theory, at some point during that period, we should have seen an eclipse, in my eyes, unless I'm missing something. I know that you have to have the nodes have to be lined up for an eclipse to take place. But when you've got the Earth aligned and the sun and the moon all aligned together.
Can I be very ignorant, Dave, please?
Go on then.
Dave, can I be very ignorant in saying this? The moon and the sun, when the eclipse is time to eclipse, it will eclipse. Us trying to say, well, it should have eclipsed then, or we expect an eclipse then, that's kind of, in my eyes anyway, this me personally, I would think I would be ignorant, because when the eclipse will come, it will come. It's all been worked out beforehand when they will come by some sort of model that we're not quite aware of yet. We haven't worked it out. Someone else has worked it out. They can predict when the eclipses are going to come and where they are, the path of totalitarian that they're going to take and all this kind of stuff. I'm not clever enough to figure out that shit out. I don't even think you are, but we're working on things and we're knowing something's not right. One thing for sure, it ain't a ball we're living on. And if we take the surmise that we're living on a flat surface, use that as a basis, we can work things out. And I think then we will get like faster to where our end goal is, you know. Sorry,
yeah.
Dave.
What I was doing, I was just taking an example. If you had a snooker table, yeah, and both them and 3 balls was aligned on that table in a straight line, then I'm sure if you walk around that table, one of them balls will block the other ball out. You know what I mean? And that's what I'm using as an example. The same, we live on a globe, and they say we've got a sun and moon at a distance, and like I say, all the 3 of them are aligned on that day, the 25th. So I know an eclipse wasn't planned to take place, but if you look at it on paper, then you would have thought something would have happened, wouldn't you? From a globe perspective.
You would think, but they can show on their model how the shadow can come from top down with the Earth underneath.
Yeah, that's
which
just
which
crazy.
I don't get. Yeah. Well, Astral. I mean, the bottom line is all you have to do is know the time period in between one eclipse to the next.
Yeah.
They can be predicted forever, and you don't need to know one thing about orbital mechanics or anything like that. In
Yeah.
fact, that was all worked out long before they thought everything revolved around the Earth or around
Exactly.
the sun.
It tells you how they do it in Ptolemy's Almagest.
So is it 18 years or something that they come around? Or?
18 years and 26 days or something like that. I can't remember exactly, but it's something like 18. It's 18 and 26 days one year, then it's 18 and 27 the next or something like that. Or there is a day difference in it. But if you put them into a graph over from like 200 or 300 years back, you'll start seeing a pattern eventually. They'll all fit into a pattern, you know what I mean?
Hey, what do you make of this then as well? Robert Kidner, for that eclipse last year, he's in Mexico, but he's still in the Northern Hemisphere. But when the eclipse came for him, it was back to front to how we saw it. He saw it the other way around.
Well, that would go along with a mirror image of whatever happens when one half of the Earth is mirrored in the other half.
Yeah, there's your observation.
The Northern Hemisphere, though, Rich. Where he is in Mexico, still the Northern Hemisphere. So surely he should have still seen it the other way around, but he didn't. He saw it the complete opposite of how you saw it.
Well, if you take a video I saw that made a lot of sense to me, if you consider that we live on an electromagnetic Earth, and not necessarily geographically, although it's close geographically to the center, like where the equator is. But if you happen to cross a magnetic line that's from negative to positive, that's where the flip happens. And I got to find that video again. Somebody did an excellent video to show that when the moon happens to cross one of those lines, magnetic lines heading east-west, he had them colored red and blue. And when the moon crossed from a blue to a red, the image of the moon was flipped to the observer. But if you're on the blue side, it was flipped back again. So that could be it. It could be a magnetic line that was crossed in Mexico. And that's one of the best explanations I've seen so far. I got to find that again. But it was very good. And I do believe we live in an electromagnetically controlled universe.
I do believe that Mike Helmet did a good video on that as well, if I remember rightly, quite a while back. And if you're close to the equator, what happens is the moon rises straight above your head. So what happens is when it rises that way, what you have to do, you have to turn around 180 degrees, and you see it, and you get the flip there once it's crossed that meridian passing above your head as well. So it's rising there, and as it gets above your head, you have to turn around. That's where you get the flip. Yeah, because it's crossing a meridian, and the moon will appear to have flipped 180 degrees as well. So it does do that around the equator, and Mexico is pretty enough near there. So if it rises above that, then crosses the meridian passing, then you would need to turn 180 degrees, and it would appear that the moon is actually rotated or flipped by 180 degrees.
Interesting stuff. That can't be explained on a ball, can it?
No. There's, like I say, because there is a lot of people everybody's looking into it now, you know what I mean, where every little inconsistency is getting amplified, you know what I mean. And I think they're running with their tails between the legs, you know what I mean. They just keep putting out more and more rubbish, yeah, to try and promote the globe, you know what I mean. Some of the videos what are coming out now is just unbelievable. The rubbish they're trying to sell us. I switched the telly on today, and it was I think it's some antique roadshow thing, and there was on about Tim Peake's doing a tour with this Soyuz capsule, the one that apparently brought him back from the ISS. You know what I mean? They're shipping this thing all over Britain to promote it. It's a load of nonsense. Well, we know it is anyway, because there's so many inconsistencies happening on the ISS. It's just unbelievable. And like I say, talking about Mike Helmet, he probably did one of the best videos I've seen in regards to how they faked it on the space station. So that is a good video. That one we did with Tim Peake, really good. You
know, you would think the first time somebody saw bubbles in space, that would be enough. Because that shows that lied to you once, they'll lie to you every time.
Yeah, but they keep buying it, don't they? You know what I mean? They believe
It's amazing. It's absolutely amazing.
Patricia sent me a message, a video today, linked to a video, and it's a bit. I think it was Marty Leeds who's basically saying it's not cognitive dissidents; they're cowards. Those that don't want to wake up, those that know and don't want to wake up and still carry on, and you're idiot and all that, they're cowards.
Yeah, they're just like Cypher off the Matrix. That's all it is. You know what I mean? He wants to go back to eating his steak.
Yeah, it's not cognitive dissidence. It's actually they're cowards. That's what he was saying.
I think some of them get a kick out of it and all, personally.
Well, I have to agree, but I take my hat off to you, Dave. Also, you, Rich, and everyone else. Like, you know, anyone who's coming out with flat Earth, they look at us like we're from another flipping world, seriously, or from somewhere else. Like, you know, we take a lot of flack. We do, but we're getting to the bottom of things, and that's why, Dave, I love you. I love you. What you're doing, man. The work you're doing is incredible.
Yeah, and it's been really because
interestingly enough, when I first come out at work and mentioned that I know the Earth is flat, I got loads and loads of stick at work. Now people just take it for normal, take it for granted that I'm a flat earther. They never ridicule me. They never take the piss out of me. You know what I mean? They've accepted it now. And you know what I mean? There's a lot of people at our work. There's over 120 people. You know what I mean? And
Dave, you can hold your own in any conversation with absolutely anybody. I mean, you can take an astrophysicist. You too, Rich, and you too, Karen. You doubt yourself, but believe me, you know so much. We all know so much, and we can all hold our own against anybody. We have the facts. We can verify everything that we say. We can, you know, come with the facts.
My favorite one.
Bollocks what they're coming with.
My favorite one is when you tell somebody the Earth is flat because there's no measurable curvature over large bodies of water, and then they go, "Well, how come the moon's round?" That's my favorite.
Yes. Yes.
It's a classic, isn't it?
Yeah.
Something, Dave, because I was just saying it is nice to know you, like you've been a friend on Facebook. I've met you, and to see what you've how much you've come along, and like Astral's saying, how much more confident. Like, I don't know what happened with your moon race presentation, but you know, yeah, you've come along so far. So proud of you.
Yeah, I actually put that together when I was deaf.
Dave, I have something brilliant to say, right? If anyone ever comes back with that the moon's round, then you can say, my testicles are also round, but my children didn't come out like marbles, did they?
Astral.
Wow.
But anyway, to change the subject from marbles, it's nice because now we've got Chris, who's starting off on his venture and his project and experiment. So we'll watch that grow as well.
Yeah, that experiment Chris did with the roundabout, I wanted to try and use that kind of an experiment to try and explain about the moon speeding up and slowing down its cycle. I think it was a good idea that when you fixed a camera, spin the roundabout, and then you had the other camera going around with it at the same time. You know what I mean? It's quite difficult to try and explain some things. Well, I find it quite difficult to explain some things because you want to try and be clear and concise when you're presenting stuff, and you know sometimes you get it stuck in your head and you start waffling on a load of rubbish about it, and you're trying to spit it out but it won't come out. You know what I mean? But it'd be nice to I like to have things to demonstrate what I'm trying to explain. Sometimes I think it just makes it a little bit easier for me and obviously the person who's actually watching it or listening. I've got a big announcement coming in a few weeks, Karen. It's going to blow you away. I can't say anything about it yet, but just keep your eyes open because something big's going to happen.
Oh, what? Yeah,
you'll see. It's
Ooh.
Big.
What? Something you're going to record?
No, something I'm taking part in, and if it goes ahead. I've gone past 2 stages now. Just got to go through the final stage of it. If it comes off, it's going to be huge, and it's going to be good for flat Earth as well.
Ooh, sounds good.
He's going to be the first person on the Tesla trip to the moon.
Yeah, I'm practicing the art skills now.
How much does anybody want to bet right now that never comes off? There'll be delays and problems, and
I've said it'll be like 5 years, but it'll be a constant 5 years. In 5 years, it'll be another 5 years, and in 5 years, it'll be another 5 years. Just like Virgin Galactic. You know, Virgin Galactic now started the new project, Virgin Orbit, on the back of Virgin Galactic. That they're going to scrap Virgin Galactic and they're going to bring Virgin Orbit in now. They're launching satellites now, you know, from the back of Boeing 747s. The same. Just Google Virgin Orbit, and you'll see they're basically going to be launching rockets off the back of 747s, and then rockets are going to carry the satellites up, and then we're going to have extra signal for our telephones and more satellite channels for our TV. So look out for that one. Virgin Orbit.
I just add, and this is personal, totally personal. If anyone is like Virgin Galactic or Elon Musk or SpaceX or NASA or anything like that, you just have to write preposterous. This is shit. Thank you. We
know that. You know what I mean? The amount of money these space agencies get is just absolutely phenomenal. You know what I mean? There's starving people, and the taxpayers forking out $52 million a day.
Amen
what for?
To that. And everybody, and they got half the people starting websites or going to websites and yelling for the government to take more money.
It's crazy.
It is.
Did anybody see the recent China rocket launch? That was quite interesting. Is it called Chenneng? Whatever, I can't remember. It's called something really silly. But the amount of stuff they're getting away with in China when they're showing these rocket launches is unbelievable. You know what I mean? It's so poor. It's like something from a 70s movie. It's that poor. You know what I mean?
Dave, they're still watching the television screen, aren't they?
Yeah.
And for some reason, we've been able, even if we're all at different stages or doing different things, we've seen behind the television, which is a bit like the Enoch thing and the veil. We've seen like behind, maybe the veil wasn't what you thought it was.
Yeah. They haven't even got 16.9 TV there. They're still broadcasting in 4.3. You know what I mean? That's how far behind the times they are.
Why is it we see these things or even understand it, and all these other ones, they just don't want to? Yeah,
it's crazy. Yeah, I think Japan landed on a meteorite somewhere as well last week or something.
Yeah, and we have, I think it's 150 million miles away, and it's broadcasting color pictures to us from 150 million miles away. When an asteroid that's moving, we're moving. It's just so ridiculous.
Yeah, the Suez capsule, it broadcasts in black and white. You know, when it shows you their engineering camera from outside, they're broadcasting a black and white signal when it's docking with the ISS. Yeah, it's 2018. I've got 24 megapixel on my phone, and it records in 4K, 60 frames a second. Phone. And they're showing us on a rocket a black and white picture in 4.3 video ratio. You know what I mean? What's going on? Don't they update the technology on rockets?
Well, evidently they do with the one that went to, was it Pioneer 1 or 2, whatever, that went to Saturn. And about every 4 or 5 years, all of a sudden the camera gets better. The pictures come back, they're much better than they were in the 70s. This thing is still going from the 70s. Come on.
It's unbelievable.
I tell you, Rich, we need to, this is a good thing about internet and a good thing about us that we've assimilated, we've checked out NASA, we've ripped them out, and we keep doing it. Because if we weren't doing this, imagine the lies that they're propagating. Imagine this shit that they're just putting on top of shit, layer upon layer upon layer, year after year. And our children are believing this garbage. I mean, young people, not even young people, anybody who's listening to NASA are believing the garbage that they're just, spilling out. It's ridiculous. So it's good that we can find all the faults with them and break them down and show them for who they are, the lying bastards that they are.
Yeah, so anyway, that recent rocket launch, sorry, it was the JAXA launch. It must have been the one, I can't remember let me click on the actual link and see what the actual launch was. Yeah, JAXA Kunatari 7 launch it was. And these are the comments. Melly, this is what inspires me. Next one by Sunil Sharma. Well done. The next one, congrats on both. This and the robots landing on Ryugu Epic. And my comment, the rocket is going the wrong way.
This is the asteroid, right? That they supposedly landed on?
I don't know if you can see it, but that's it there. Look, that's the rocket. It's going the wrong way. It's going down. Yeah,
it certainly is.
And I don't know if you can see my comment, but I don't know if you can see it. But
I see that. I see that. This is what inspires me.
Oh, can you? Yeah.
Put two brain cells together, please.
Yeah, there it is. It's going the wrong way. It's going down. The first thing about it, it only went up for about 30 seconds. Then it was leveled off. You know what I mean? And then it was going down. And then they switched to PlayStation 2 or Nintendo 64 graphics. Unbelievable. and they're saying it's epic. Yeah, epic. There's nothing epic about cartoons. You know what I mean?
Yeah. Do you ever think they just keep trying to test and see how bad they can make stuff and have people still believe it? I mean, some of it is so bad. It's like it's got to be done on purpose to see if people will still swallow something that horrible.
Yeah, well, it goes out to the cheapest. The person will do it cheapest, won't they? You know what I mean? Yeah, you'd think with the money they're getting, you won't be able to tell the difference. Yeah, because they'd be using so far advanced technology. But I'm sure you watched the latest NASA launch. They're still using that PlayStation 2 graphics, what they've used for the last 10 years.
Yeah.
They haven't even changed it. And they're still getting away with it. And they're still getting comments like, this is what inspires me. How can that inspire anybody? You know what I mean? If you look at that with a critical eye and you're like, hold on a minute. Say again.
Said that because now NASA, sorry, you shouldn't have said that because now tomorrow NASA are going to update that shit graphics that they've got, haven't they?
No, they won't, pal, because people are still buying it.
They will.
While people are still buying it, mate, they'll just keep doing what they're doing. They don't have to change anything. You know what I mean? They're showing like so many inconsistencies and rubbish CGI, not even the standard of CGI. You know what I mean? Like if you look into the movies and you see the CGI, you can't tell the difference these days. In fact, I reckon the special effects on that film Gravity are still better than any effects I've ever seen on the ISS. Ever.
Yes, I agree, because even in the last weeks, I've put two out. One that I saw because I just saw a glitch, saw it, and then the other one obviously was Skyfly, who'd been on the with the tomato sauce bottle.
Well, the French guy, is it the French guy who plugged the ISS? Well, he did a live broadcast. Is it for a German guy or French guy? I can't remember. I can't remember his name now. I'll dig it out in a minute. But he did a live broadcast in his native tongue language, and I watched it. And you have never seen so many glitches ever. They've got like a time capsule, like a silver sphere, and from what I gathered, it's some kind of time capsule. What they're going to be using, and the amounts of glitches. You know, when you see the odd little glitch, it's just a glitch from beginning to end. In fact, I'll try and dig it out, and I'll send you the link. And when you watch it, it's unbelievable. It's just 20 minutes of pure glitches from beginning to end.
Yep. And no one says anything. Not one politician says, hey, do we need to look into NASA's footage to see if we can see that? Oh, look, I can see it's a piece of material. Or, oh, look, there's a paused astronaut. Bit of a shame, isn't that?
Yeah, or a paused Earth even. You've seen those. Where the Earth isn't spinning, then all of a sudden it is. Or astronauts that start fading away as they go around the corner, or coming across on a harness. Or how about the magic little doll that appears showing that they're 100% using green screen technology?
Karen, I've just actually found it. So what I've done, I've just messaged you the actual link to this video with all the glitches. I'm just doing it through my phone, so...
Okay. I can't screen share for some reason.
No,
I don't know.
Yeah, it's... all I've done is just sent you the link for it, and you can have a look at it at a later time. It's Alexander Gerst, the guy, anyway. Yeah, so I've just sent it, yeah. Just have a look how many glitches is in it. It's unbelievable, I tell you. Glitch City.
What is the
Right.
footage of?
It's just an interview from the ISS from I think it's the German, the German TV. Just doing an interview with him in his native language, like. But I just clicked on it because I was looking through ESA videos, and that was one of the more recent ones. I'll tell you what, they have got interesting on that channel as well. I don't think it's ESA one. I think it's a German space agency, but they've got an interesting rocket launch, and it's a little bit like the Go Fast rocket, what goes off and it just stops dead. Well, interestingly, the German one does exactly the same, but it stays there for about 10 minutes in one place. It's unbelievable. I'll have to dig that one out for you as well, because that's interesting, that is, because it just stops dead. Yeah.
Okay, I've sent Rich that little video, and then I sent him the one of the dog. But there was only about 5 seconds of this dog. But as it goes up, suddenly its whole shadow flicks the other way. It's really bizarre. But it's filmed upside down. But it's still happening, isn't it? When he has the camera the other way around, we're just not noticing it. Because he's filming the sand. Yeah, so I've sent those to Rich. So I sent them, yeah.
Yeah, but like I said, that's the amount of glitches, and to get away with stuff like that, you know what I mean? Sometimes you've got a sound delay on the ISS, sometimes you haven't. You know what I mean? When Nixon talked to him in '69, he got a perfect signal, didn't he? You know what I mean? If I go to the back of the warehouse on my phone, yeah, I've got a signal. 2018, and I can't get a signal in my own town. It's ridiculous. Right, I'm just going to take a quick break, and I'm going to have a quick cigarette and make another drink. I'll be back in about 5 minutes.
All ready, Dave?
All right, see you in a bit.
I'm looking at this video already, and 20 seconds into looking, I see a major glitch. Crazy.
Which one are we looking at? Because I've got live Alexander, whatever. Is that it? That one?
I closed it out now. Hold on.
I'm just wondering if it's possible to screen share so we can all rip it apart.
So I don't seem to have this. I can't screen share, so it's not going to be me.
I can do it. Let me get it up here. Let me find it first on my main computer. Yeah, live call, Alexander.
Yeah, it was that.
Gerst-Zurn.
Oh, okay.
Yeah. All right, let me drag this over.
Thanks, Rich.
You got it. All right, I guess you can see it. This is the one. Now I've got it muted. I wonder if there's a delay. That was the first question I had. There's already, look at this thing. It's jumping. I don't know if you can see it with the detail. You should drop this link in the chat. Oh, there's just like, there's like 4 glitches already.
Anyone in the chat who sees anything, let us know, please. Let us know.
I'll put it
Look
in
at
the
that.
chat.
Did you see that?
Yeah, I saw that.
Let me get rid of this.
You can slow it down a bit more, can't you, Rich, as well?
Yeah, I'm gonna wait. I'm waiting for the next good one, and then I'm gonna. I mean, it's already glitching. I mean, if you can see this as close as I can see it, it's jumping all over the place. Wow, he just jumped. It's like the ball's on a different time period than he is. A little. Did you see that jump out? Let me go back here.
His fingers in the ball.
.540. Let me go to 544. Look at that. His hand does weird stuff.
His fingers.
You see the ball? It turned into 2 balls for a second. It came back together.
Yeah, it's because he's not really holding it, is it? Isn't
No.
it?
Yep. You'll see at one point his fingers, when they're over here, they kind of do this
Blurry.
little melting thing.
Blurry, like there's two sets of hands.
Now, here's the thing. Think about it. The millions of dollars is supposedly spent on this, and they're up there giving their signature on a sphere ball.
Yeah, why not a plate?
I mean, what is the accomplishment? What is the great accomplishment for mankind with this? What do we get out of it?
What's on that little laptop behind him there? That timeanddates.com. Is it?
Oh yeah, back here.
Yeah.
Well, that's the it shows the paths of the ISS as it supposedly goes around the Earth.
Yes,
And
it's
yeah,
swing. Woof, woof,
yeah,
70 times a day.
and this is day and night. And as you can see, I don't know if you can see, but this was obviously in the summer because it's showing the whole northern part always in light.
It's not really moving though, is it? Because they're going round 17 times a day.
Right.
I'm looking at the reflection in that ball.
Oh, they've got the reflection down pretty good, but it looks like there's a person actually there.
It does, doesn't there?
Yeah.
You know,
Oh look, they look like they're sitting on something.
yeah, but I actually have to think, and really, I truly believe he has got that ball in his fingers there. If it ain't, it's flipping good.
Yeah, but the ball doesn't look real.
No.
Well, did you see that? It just split
Yeah,
into
yeah.
like two different balls. I'll go back a
Look,
couple
it looked
seconds.
wrong. It just looked wrong, that, Rich. Yeah, it did. The movement.
Yeah, well, you'll see on this side, it kind of splits out and comes back together.
When he grabs the ball.
So he's looking at the camera going for the ball. Then he looks at the ball. Look at that. And then it jumps
Yeah,
back together.
Yeah, there was a little glitch there. It stepped. Do it again.
Can I tell you something? You know, don't you, that they've made these little videos on Facebook where on the day that Trump, I even put the whole thing in the Sun and Moon Facebook group, where basically you can make anybody say anything and do anything it's all computer graphics. This is what this is.
That's knackered, that just jumped then.
All they need to do is just film him once, and then all they do is they computer graphic it and move him around. He's not really moving. He's not holding that ball. He isn't there, nothing. It's all computer graphics. They can even make him say what they want him to say.
Yeah, see, this looks like a magnifying glass because everything behind it is blown up bigger. And then it comes back together with the ball. See that jump? Wow.
Yeah.
I happened to hit it just right. But think about it. What the hell is this benefiting us? What benefit do we get from him?
You know, they
Touching
waste time. They waste the time up on that flipping space station, supposedly doing shit, holding a flipping ball and
Wow.
throwing snot out of their flipping noses to catch it in a tissue or whatever shit they do. You know, and like Crow said the other day, the weight of a keyboard up in space and pound for pound, how much it costs to launch a rocket up there. That is a total waste of money, a total waste, you know, for what?
Well, think about the waste here. He's got a laptop, and what's it got? It's got their position on it. Date and time overlay.
Yeah. Why have they got the microphone? That weighs what, a third of a kilo at least, doesn't it? A microphone doesn't. They're not light. That's weight, payload, money, taxpayers.
I see you found the video then. Have you seen it?
Oh,
Ever
yeah.
seen so many glitches?
Well, yeah, we're just going through real slow, just on a little part of it. It just makes no sense to me why we're spending money. Let's just assume this is real. Why are we spending money to have some guy up there spin a ball around in his hand and sign his name on it? Do we need we need him to go to space to autograph a ball?
Yeah, shame he can't get his thumb stuck in it.
It looks like it says 2068 on there. Could that be right? Those numbers.
This is 2018.
Yeah, but the numbers on the ball, it looks like they're saying the right
Oh
way.
yeah, this is 2068. So I guess they're saying 50 years from now, something. I don't know.
Yeah, I think that's what they're saying. Just watch all the glitches. Look, his fingers are glitching. Look.
Look at that. Wow.
What I want to say is this: how can those numbers be shown as 2068 in a ball? They shouldn't be that way. They'll be upside down, inverted, won't they?
No, I think it's just imprinted on the surface of this probably balloon. Yeah, I mean, it probably isn't even what it appears to be. It's probably not even steel or whatever metal.
Yeah, helium filled.
Yeah, look at the nice rim there.
I think it's CGI because it keeps glitching out with him as well. None of the background is glitching out, just him. Have you seen him when he's swimming yet? He goes swimming in a minute. It's amazing. Yes,
Look, it goes on and on and on with this stupid ball.
Yeah, one of the 4-year-olds asked him to do some swimming.
Right.
I'm gonna see if I can find it. Oh, here we go.
Can I just say something, guys, please? I have here, right, a silver ball, a chrome ball, steel ball. Now, if you, Dave, write 2098 or whatever on a piece of paper and hold it up to me and I shine this, and you look at the reflection there, it ain't the same, man. It's impossible. It's impossible.
Yeah, we know it's all CGI anyway. Here he goes. He's going swimming.
Well, look at this. Look at this stupid puppet or whatever it is. Spacesuit. This is probably better in a vacuum than his real spacesuit. So let's see what they do here. Yeah, this is worth $50 million a day or whatever it is. Oh, look, he kicked the keyboard. Did you see that?
Yeah. See how he's looking at the monitor to look at himself?
Yep.
There we go. Oh dear, look at that.
So he was swimming and couldn't get anywhere, right? But yet there's supposed to be these turbines that turn that cause it to be able to go 67,000 miles an hour to keep up with the Earth. Using the same force he is, pushing against nothing.
Oh, there's a weird shadow just moved in that bit behind him. The shadow, look. I don't know. It went before he did. I know his foot's in there now, in the shadow in the back, above the ESA thing.
Oh yeah, there's a it reflects back here. Look at all that glitching. Wow. Let me go back to that.
There's loads of it. Always. There's glitches all the way through it. Look at all that.
Look at that. His right arm just disappeared and came back.
But none of the background was glitching out either, is it? Have you noticed?
Yeah, the background looks fine.
With the way he has to move when he hasn't got his feet on the ground, it's actually, oh, golly.
Yeah, it's pretty bad.
It's absolutely amazing that he can stand up then, isn't it?
That is just so fake. Look at his blue suit's glitching. Nothing's glitching behind him. Fake.
Yeah, look at all that. No, you don't understand television technology, Astral. This is what happens when you lose signal for just a second and it comes back. This is the excuses you'll hear. And yet, it only happens with him or the object he's dealing with. The whole thing should glitch. If you're losing the signal for a fraction of a second.
A good example to see it all glitching out is if you watch the Formula One and you watch it from like when they've got the camera fixed on the car, and what you do, you get a lot of glitches on that, and the whole lot glitches out, not just the car. Yeah, you get the whole scene, the whole frame glitches out.
Yeah, the road, the barriers, the spectators, the sky, everything. Exactly. And his suit glitched, but the background didn't. Fake. I love you, Dave.
Wow. Something just disappeared right here where the pocket would be. Let me see if I can catch that. Right about now. Come on. Little blip that comes on. Yeah, there it was. I don't know if you can see it.
Yeah,
See
I did.
The black stripe here, that's where you look.
Yeah, look at his badge as well. Look at the German patch on his arm as well.
Wow. His whole waist just jumped ahead about 2 inches. Then his body caught up. I mean, it's incredible fakery, and people just think it's real.
His
Just because
body
they're
doesn't
told.
look right, does it? He looks like he's got enormous, great shoulders, and
It's like as if they've got them balancing on something as well. They're like, you know, when a Jack in the Box comes out of its box and they're like, go like that. They're always
Yeah.
like this, like as if they're like balancing on a ball or something.
Now, why does this little thing have like a cord attached to it? See
No
how it
idea.
follows?
Watch the glitches now.
Wow. Wow. Did you see that microphone? It just keeps. It's like every time they introduce something new, it just has to glitch out. I guess it's another CGI channel they got to put in.
Look, he's looking at the monitor. See him? He's not looking at the actual thing. He's looking at the monitor to see where the ball is in 3D space.
Absolutely. Every time. Like when he needs to go grab it, he's not looking at the ball, he's looking at the monitor.
He's looking at the monitor because that's where he can see the object in 3D space. There's nothing in front of him really. It's just got that object in 3D space, and that's where he needs to look at it. Tim Peake does the same when he's doing his table tennis and what have you on the PISS.
Watch this part of the ball, like right here. This part of the ball disappears.
The PISS, I like that, Dave.
See it? It's like
Yeah.
his suit blends into it. But no, it's real. It's normal for the suit to blend into metal in
It's gotta be-
space.
Gotta be real because it looks so fake.
anyway,
Exactly.
we've seen Hori do the same thing as him.
It is chroma key because it has to be.
Well, if I was to be very, discerning now, I would say his suit against the background does not mesh. There's something wrong. Doesn't look right. And I would have to say that is green screen. Look at it. It doesn't look right.
Yeah, I was going to say that. It's just something just doesn't look right.
Yeah, it looks like
Don't you think every now and again that
nothing.
one of the lights might sort of flicker or something?
Yeah, well, also, right, if you look at all the lights behind him, right, but yet they're not, they're not illuminating behind him in a way. Look at his head. He's got that fucking chrome domia going on there, man. Jeez.
Yeah, surely
Seriously,
the light
look at the
is
shine.
shining on the top of over the top of his head.
Yeah, look at the ball. There's lights in front, obviously, and on top, and yet the front of his head is really kind of in a shadow. Now it's getting illuminated more. What did they change in the lights?
Yeah, but exactly.
Look
But Rich, if you look behind at that head height now, behind him, there's like 4 or 5 lights more at head level, just above his head.
Yeah.
All across the top there. What are they doing? They're not helping his suit lights up. Look at his suit in relation to those
I know what
lights.
you mean, Astral. What is happening is that is a fixed picture and nothing's moving. Like if he was moving and they were filming something that was real, everything would be moving, but everything is stationary.
Yeah, true. People can't see that, and I'm trying to help them see it. That's what I'm saying. Like, the lights behind are not helping anything. They're nothing. He's just a fake background.
Yeah, it's like when he had this dial. Let me find it again. This stupid, whatever it was. Oh, what's this? We got cheese. More glitching. Oh, did you see that? Whoa, that's a major glitch. Watch this box. Here it comes. Look at this.
Really?
It just rewrapped it. It rewrapped itself live.
Do that
Oh
again. Do
boy.
it again.
Would you like that gift wrapped again and again?
Ooh.
Oh, come on.
It's the Muppet Show.
It's unbelievable, isn't it?
Oh, unreal. You know, even if I did believe in this, by now I'd be like, uh-oh, something's not right with my belief system.
Yeah, nothing else. You know, nothing else is moving at all. Nothing.
Nope. Well, what I wanted to show was, you know, that stupid antenna or whatever, or tether, whatever it was to that little doll. It was moving all over the place, even when it was not moving. But yet you have these little cords here, not
Just-
one little fraction of an inch of movement.
Yeah, if you watch his eyes, now he's looking at the actual camera, and then what you'll do, you'll see him, he'll keep putting his eyes down to the monitor. See?
Yeah.
He's looking at the monitor
Absolutely.
now. In a minute, he'll look towards the camera. See? Because he's looking where it is in 3D space.
How does he even get his hands on it?
I don't know. I was thinking the same thing. It's a very unusual grip there, isn't it?
Yeah. Also, if you watch Mike Helmick's video and they show you the technology, what they use, you know, for holding objects in 3D space, it looks perfect when they're doing it, you know, in the actual 3D space itself, the augmented virtual reality.
Yeah,
What?
this is what they're training to do, isn't it? How to hold a box that isn't there.
Again, tax money well spent. Nice gift wrap. Oh, this is a present that the
So
previous
sick,
astronaut
isn't it?
left me.
Absolutely sick.
It's so annoying, isn't it?
Well, actually, I would prefer if he unzipped his little jumper suit there, put it inside his belly and zipped up his jumper suit again, because then I would be like, okay, more convinced, if you understand what I'm saying.
Oh, this was the birth of the ball. That's what this was. How come the ball wasn't floating at the top? It was at the bottom of the box.
I don't know. It looks kind of good enough, that, you know, in my eyes at the moment.
Look at that. Now it's a totally different color. It's not shiny at all. Notice how all the shine went away from it? Yeah, that's real, all right.
Just go back a little section, because it almost looks like the box lit up a little when he opened it. Try that. Look carefully. It looks like it lights up golden.
I like how shiny it all is, and then all of a sudden it's dull.
Yeah, but watch when he opens it. Just when he
All right.
opens it. Look at the coloring.
I mean, what the? It doesn't even look natural.
Yeah, it's because it glitched, Astral.
Look at that.
Yeah, that's true. On his wrist, yeah.
It gets shiny when he first gets out of the box.
Oh, Dave, we can't hear you.
I was just saying it was dead shiny when it was in the box, and it brings it out. It's like the moon, dull.
Yeah. See?
And it
All
glitched.
all the shine's gone. Except for when it glitches. Now look at that. Look how dull that is. It's not even, it doesn't even look like it's painted correctly. This is, I mean,
See, he's looking at the camera now. Now watch him in a sec. You'll see him look down at the actual monitor to see where it is in 3D space.
yeah, and to see if his hand still meshes where it should.
Yeah, we might have to wait.
Anyway, you know, what was it we were watching all on Facebook last week after the hurricane? Was that the newsman sort of up to his waist in water, and then someone walks behind him. They're going, it's so windy here. And then somebody walks normally behind him. And then there was this bit I saw about these news people. What it was is they had a satellite link up, and then people noticed that the same cars went past both of them.
Oh
You know,
yeah,
there's
that's CNN.
Yeah, look how padded his shoulders are and his arms. It looks like he's got a 70s jumpsuit on or something like that.
They never look right, do they?
No,
on it,
like I
though?
say, he looks like he just popped out of a Jack-in-the-Box and is just on the final waddle, doesn't he?
Yeah. You know, I'm going to change it.
Floating around like that or having difficulty and the ball's moving. Why aren't the wires moving or some other things just moving a bit or the light?
Exactly. That's what. Exactly, Karen. They should
You're
be.
going to have vents going. Even the computers are going to have, like, laptops have sometimes have what do you call them, fans in them. So they'll have them, like, they'll do something.
And not only that, when you're recording a screen onto a screen, you'd probably get a bit of flicker on that monitor behind you as well.
Look at this thing moving. The tether. See how it's going up and down? And even when he lets go of it, it's still going all over the place. But yet these, nothing. Not even a twitch.
And you know that picture in the background? It's not moving on the computer.
No,
That's what I've just said.
No.
And you would get probably a little bit of flickering from that because you're recording the screen on a screen, and you normally get a little bit of flickering. Nothing.
Well, let's take the beginning, because this is going to show their position, right? This is at the beginning. Now let's go 19 minutes later. It does show it move a little bit. Here they are crossing the equator.
Yeah, it did.
Yeah, hang on a second. Do it again though, but because 17,500 miles an hour.
Yeah, exactly.
how
In
much
20
would
minutes,
they
in 20 minutes, it
traverse
should be longer. So
And anyway, it only might have moved because
here it
that's
is,
where
right
the
here, I think.
thing is.
Well, anyway, when you go 20 minutes later, watch how much the screen changes. I'm looking at this edge here. That's it. So, yeah, 17,000 miles an hour. They've gone a quarter of an hour here, 1/5 of an hour.
That ain't right then. That ain't
Uh-uh.
right. Not, you know what? They can go over Africa. How fast?
And it all
They're
moves at
over
the
it.
same rate.
You know what makes me laugh though? As it's 17 and whatever it is times a day, they'd never know whether they were coming or going.
Do you know what makes me laugh? If someone tickles me.
Let's look at it in double speed and see what it looks like. I've never done that. You know, it actually makes the glitches stand out more.
It looks better, Rich, because he looks more stupid.
And it still looks like a Jack-in-the-Box.
Exactly. Oh boy, it really does magnify the glitches.
And do you know what? This is supposed to be 60 frames a second. This is nowhere near like 6. I know you lose a lot of quality through the actual Hangout, but if you watch it on the actual YouTube channel, it's supposed to be 60 frames a second, isn't it? It's nowhere near 60 frames a second. You can see now.
Wow.
It would still be smooth at 60 frames a second.
I mean, this is Glitch City. I've never seen one so glitchy.
Yeah, I couldn't believe when I watched it. I'm just like, wow.
I think they're banking on most people not waking up, really.
Most people don't want to even believe that this could be fake. I mean, I can tell you, I was into Star Trek. I used to get up at 3 in the morning when NASA was doing anything special, like with Apollo 10 or 11. I didn't miss any of it. There was nobody wanted space to be real more than me. Nobody. And, you know, when at some point you're intellectually deceiving yourself. And that's why the trolls keep coming back, Karen. I'm convinced. I've thought about it a long time. Of course, I'm not a psychologist, thank God, because I don't like the field. But the only reason to keep coming back over and over and over again to the same flat Earth videos, and they on their channel have made, and I'm going to cover this in the video too, they have made playlists on their own channel of different, how to disprove flat Earth, all these different things that mentally themselves they lean on as a crutch so that they can keep believing what they believe. And yet they keep coming back to flat earth videos. You know why? It's because they're not really convinced themselves that they live on a ball. And they want to cut.
Rich, it says it all there, what you've just said. If they're doing videos against flat earthers, then it just says we are fake. It's screaming out, we are fake, and we need to do something about it. That's
Yes.
why it says
My thing is
out loud.
Well, I don't believe in UFOs. I just don't. Well, I mean, I believe in UFOs, but I don't believe in aliens. So for me to go and keep going to alien type of videos and leaving comments, it just makes no psychological sense. I don't believe in it. Why would I keep going back to something I don't believe in unless I wasn't really sure that I didn't believe in it, and I had to keep assessing my own thoughts.
You see the shadow of that person or something, whatever it is in the ball.
Say again.
Carry on. There's the reflection of the ball, whatever that is in the ball. There's a person there, isn't there?
It looked like it from one part, but I don't see it now.
There you can see it looks like Doc from Back to the Future or something.
Great Scott.
Well, how come you never see his reflection?
It may well be him.
His head got a bit lighter, and when he was standing up here, it did shine on him a little bit.
They have the effects for to have his reflection in the ball. We've seen that in a lot of films. We've seen it in 1992. Is it from the Terminator 2? Judgment Day. So that film was what? How many years old was that film? Over 30 year old.
Yeah, for real. I mean, 2001: A Space Odyssey. When was that? The 1970s or whatever.
67.
Yes.
Yeah, before the moon landings.
I keep going back to this, how he's showing that you can't get anywhere in space. You can't keep waving your arms and get anywhere. And that's what he's showing. He gave up. And yet that's how they claim it. All these satellites and everything move.
I wonder, right, and I'm serious now, if he ate enough carbohydrates and he farted, could he propel himself with his own fart? And I'm serious now, could he?
In theory, yes.
So they're obviously eating the wrong stuff.
Well,
is it what they're in? It's okay if they move really, really slowly, but the moment they try to move faster, which is fighting whatever this is they put them in, then it can't go anywhere.
Yeah, it's lucky they don't, when they have a pee anyway, they don't fire themselves to the back at the space station.
Yeah. Well,
the women, when they have a piss, don't they?
Well, they've shown urine dumps, how that's supposed to work, how they dump urine and stuff, but they never show you what they do when they have to take a crap. What happens? How do you get that out of the suit? Or are you going to tell me that? Mad. It's just crazy.
Yeah, I think that woman, that is it the Italian woman? Or I think she did a demonstration on it. They've got some kind of vacuum pipe. It's a load of nonsense.
Oh my Lord! Something else for the 20-volt batteries to run. A vacuum to evacuate their feces.
It's unbelievable.
I thought they were going to stop showing us stuff from the ISS space station.
Well, this was on the German channel. I'm not sure it weren't the Easter channel. I think it was the German channel, weren't it? But like I say, it's a good channel to go through that because you've got some interesting rocket launches on there. So it might be worth having a little look through the earlier videos of the rocket launches because these rockets are going straight up what they're launching.
Yeah, that's a German Aerospace Center channel.
Yeah.
Can I just say something? Also, I'm serious now as well. I was listening to watching a video, and they were talking about radiation and stuff and how they would combat this radiation. They were probably talking about Van Allen radiation belts. And they were saying that, well, we'll go to the back of the spaceship. There's a lot of water about materials and things and all this water that they've got there. They can more or less bury themselves in this water and be protected from the radiation because radiation wouldn't, it's a good conductor, they said, or a good, it like envelops them and it won't go through it. I'm thinking, Man, this is just garbage you're feeding us now. Kids are listening to this, believing all that shit. And I'm listening to it thinking, what's this junk you're giving us now? You know, have you heard any about that? Anything about that, sorry?
Mm-mm. I like how these videos, you know, it's like the rocket's going up, but they always have to cut away and show you what the crowd's looking at. This is, I guess, space in Europe too, Germany.
Yeah, I think the Germans are trying to launch rockets. Oh my God, Sputnik 1. Like the dog.
I mean, are we ever going to see a launch here? Oh, brother.
I think it's the rocket launch number 5. I think they've launched. They're on the 7th launch now, or the 7th rocket launch. But the rocket launch number 5 is quite an interesting one. I can't remember what it's called. It's got a German name. It's called number 5.
Let's see. See if we can find it real fast. Oh, about as real as it is.
Hey, Rich, you like that message that person put about fuel and planes and stuff?
Yes, absolutely. Another lie.
It's not the Icarus one. It's called something else. I'll know it when I see it.
It looks like a bunch of nothing, all of these.
Yeah, a lot of it's nonsense on there.
Mars landscape. This is going to be interesting. I like that how they're trying to say now that, look at this. You know, air has no frictional component to it. When our rockets, when our balloons go up, you know, they go up 130,000 feet. Some of them, they come back. They're not all fried up from engaging with the atmosphere. And yet, here's Mars with, this is crazy. They even think we used to buy this stuff.
It's all a joke.
Isn't it?
Well, it's not actually a joke because, like you say, all that money they plow in, which they're using for the fake wars, hearts, and all those other things, whatever else they want it for. But imagine, you know, like we hear quite often that America's like quite like you know, owes a lot of money and on the brink of, and 50 whatever it is $1 million a day goes to NASA. I don't get that.
Yeah, there's a lot of nonsense on this channel.
Yeah, this is supposed to be descent to Mars in real time. That's real. Oh my God. This is so nuts.
Well, they definitely indoctrinated us, haven't they? And they definitely programmed us.
Is this, sorry, Rich, is this CGI or is this supposed to be a real landing on Mars or wherever it is, yeah?
I don't know. That was a Jiffy Pop thing. What the? I mean, kids' cartoons in the 60s were better than these animations.
Seriously, Flash Gordon. But are they trying to give us this as reality or is this CGI?
I hope it's CGI instead of reality. Look at that.
Look at the flames.
Did you notice they cut out just a few seconds too soon? We got to do that in slow motion. Oh, hilarious. I didn't know this was the Comedy Central channel. Where am I going here? Multiplayer?
Those flames look hot, don't they?
Yeah. Watch this. They cut out just a little too soon. But I got to give them this though. Unlike the moon landing, they did kick up dust.
That looks real though. It
Looks
looks
the
real,
size
gotta
like
admit.
a frisbee or something.
Oh my God.
I
I'm gonna have a heart attack in a second and die because that is just junk. Sorry, Rich.
I'll tell you what it is.
It's unbelievable.
Totally. People believe this shit.
This is where they got the
Elon
idea
Musk,
from.
right? I was flat smacking some people today, and I talked about this Elon Musk and the space, the car. Do you believe that was real? Oh yeah, of course.
Oh
it was
my
real.
God, it's
They were
unbelievable.
convinced it was real.
Interestingly, when you look at the Discover satellite of Earth from 1 million miles away, that one I'm sure you've seen the epic image where the moon crosses the Earth. Yeah. Well, that was from a satellite apparently 1 million miles away. Yet the car you see in front of the Earth is the same size Earth it is from the epic satellite 1 million miles away. So you know what I mean? Something's not right there. Yeah, they've got the distances way wrong there. Because I've got the two images side by side, and the Earths are nearly the same size. The one on the Teslas is slightly bigger, but only slightly. But it's not 1 million miles away smaller.
No.
You know what I mean?
I still want those Tesla tires that can hold their air in the vacuum of space and don't melt. Here in Arizona, it gets 110 degrees Fahrenheit, and our tires only last about 3 years because they just melt. The rubber just melts off, and yet they can stand 4 times that temperature out there in space.
Oh no, not the Chinese landing. Have you ever seen the actual the craft coming down on this video?
No.
Oh
look
my
at the
God.
Earth. Oh, please be larger.
Well, they broadcast it in China, and it shows you the actual capsule landing. It's unbelievable.
Wow. Notice how their moon looks a lot different than Apollo's. All these different moon landings, if you look at the surface of the moon, like Japan, China, whoever says they've gone there, every surface of the moon is different.
Where's the mountains gone?
Exactly. But Apollo, they supposedly landed 4 or 5 different areas, and the moon looked exactly the same. But no matter where anybody else goes, it's different. That's nowhere near what ours look like.
Yeah, that horizon's about 30 feet away.
Mm-hmm. And look at that Earth. What an interesting midnight blue it is.
That's just nonsense.
We have blue moons, and now we have blue Earth. Let me see if I can find what's it? China moon landing.
Sorry, Rich.
Yeah, you got me?
Oh, you just cut out a bit, but what did you say?
Oh, I said I was just talking about China moon landing. Is that what it was that he was talking about? Is this it?
Day.
Yeah, that's not the one I look at. It shows you it from the actual the lander itself. Like you can see the lander, but you can see this. It's just nonsense. Absolute nonsense.
Did you see that freeze frame there for a second? There was no movement.
Can I just say, I was baking a pumpkin pie a few years ago. Looked
perfect
very much like that. Looked very much like that.
Watch them all clap. Well, they're not very emotional Chinese, are they?
Yeah. Look at that. What the hell is that? Wow. The octagon moon. Oh, I got to see that again. The stop sign moon.
Stupid, isn't it?
What if the moon is always facing the Earth, wouldn't they have to look up at 90 degrees to see the actual Earth instead of seeing it on the horizon?
Now that I don't know. That takes somebody
Dave,
with the.
You're absolutely spot on there, because our perspective from Earth looking at the moon, we're looking up. But the perspective of the moon looking down at Earth, you're looking down at Earth.
You'd have to look 90 degrees.
Exactly. Nothing matches up. If you look at all the landings that they've had on the moon, where they landed, apparently, supposedly, nothing would match up. Would not
Remember
match
them
up.
craters? Them craters coming down would have to come down in a straight line, so it'd have to be a straight path. And you'd have to, and if you was on the moon and them craters were coming towards you, what would you have to do? You'd have to look up, and they'd have to come down on top of your head, wouldn't they? So you'd have to look up to see the Earth as well.
Wow. The
Yeah,
hell is that?
that's what I saw. The video like that.
Oh, stop
Oh,
making me
my.
laugh, please.
You know what really gets me? I got to pull this up. I'm not getting what I wanted.
Really strange. I just looked in the chat room and I saw this person's name and they're called the Mick. Taking the Mick.
Taking the mic.
Why can't people tell that these are cartoons?
Because they're real. They're on flipping the internet, man. They must be real.
Told us, isn't it? That's what it is. That's what we've been looking at for years.
Yeah, well, I've actually compared my son images to their images, and they don't look nothing like it.
No.
No.
Well, we know from the eclipse and people that did videos then that the sunspots, they actually go in a clockwise rotation around the center, but NASA always shows them going left to right across the disk.
Yeah.
But you have people like BP Earthwatch will say this is actually the sun.
You know, I asked 3 people today at the same time, what color is the sun? One guy who was a bit older, he was like 36, I believe he said. He said yellow. When you were young, what color was the sun? He said yellow. The 2 other guys, a bit younger, they both said white. And I said to them, well, yeah, we look at the sun now, it's white, isn't it? They're like, well, yeah. The other guy said, no, it was yellow when I was a kid. And I agreed with him. When I was younger, the sun was yellow. And nowadays, when I look at the sun, it is very white. Or is it just me getting older? My eyes are getting buggered.
It does appear very, very white, and I always remember it as a kid being yellow, but I can't be 100% sure. You know what I mean? It's something you probably never really took much notice of as a kid. You know what I mean? What colour the actual sun were? I mean, we always drew it as a kid as yellow in the sky. Can you remember when you drew a picture of a house and the sun? We always did the sun yellow. So
I was looking at some of these. I don't know if you've seen these transits of Venus across the sun from these Soho images. The Venus is actually transparent. You can see the sun through it. Not all of them, but I'm looking for the right ones. But these are supposed to be actual images of Venus crossing. And what most people don't know too is they might know that the Mayans were flat Earth people. They didn't believe in a globe or spinning globe or whatever. They believed we were the center of the universe. And they accurately predicted, here's a good picture of it, I think, where you can see the sun through it. They accurately predicted not only this 2012 transit of Venus, not only did they predict that back, 2,000 years ago or whatever it was, but they also were able to tell the 2 places on Earth where you could see this thing in totality.
yeah, I believe that. I truly do. You know, the ancients were told that these people were living in the prehistoric ages, but they was living in a time where the intelligence level was a lot higher than it is today because we've all been dumbed down by the system.
Absolutely.
I just say I have my take on things about that, right? It's because we are so we're man-made now. Everything is man-made. We're not at one with nature anymore. I am a total nature child. Honestly, I love being outside. Get my hands dirty. Get out cold. I don't like being cold, but I love to come out into the nature. And since we've been kids, we've always been going in plastic shoes. Karen, grounding. We need to ground ourselves. We need to have bare feet in the flipping grass, in the soil, in the sand, in the water, whatever. We need to ground ourselves, and we don't do it. And I think if you take an average person from 0 to 20 years old, how many times are they actually barefoot in that lifetime from 0 to 20? It's probably not many.
Astral, you're breaking up a lot.
Yeah, sorry. How many times are we naked? Oh, not naked. Are we barefoot? From 0 to 20 years. Not many times, I would imagine. Not many, when it should be at least every day for 20 years, but it isn't.
I'm glad you brought that up, Astral, because I have had chronic insomnia. And for the last week, I have made it a point to ground myself. And I've only had one day where I haven't slept well since then.
Yeah, well, there you go. It does work, Rich. It definitely works. I know I ground myself as often as I can, and I know it. I feel better for it straight away.
Have you seen these before, Dave?
Yeah, yeah. We actually did it on Karen's show one time. I don't know if Chris Monk Seeley, the Flat Earth Shill, was on the show at the time, but yeah, we've looked at this on a few occasions. Can you remember, Karen?
Yeah.
Yeah, these are the paths of the lunar eclipses, and the only reason I'm bringing this up, I like to bring this up every now and then, because when I did that video where I was talking about the moon can only be 70 miles across because a shadow can only be the same size or larger than the object that's blocking another object. So the moon can't be any wider than 70 miles across if that's what's blocking the sun, which of course I don't think it is. But at the beginning of that, I was just showing the insanity of NASA and mainstream science, how they always dumb us down. And they were showing a person spinning around and another person spinning around that was supposed to simulate why the moon was moving from west to east. And that wasn't the point of the video at all. I just wanted to show the insanity of NASA. So I included like a 20 or 30-second clip of that. Didn't even talk about the path because I knew somehow they would have the model work out so it would work. But there's a couple things that people said. People went on forever in like 8-page dissertations telling me why the moon would always have to move west to east, without realizing that if the moon doesn't go on a straight path, it's either speeding up or slowing down when it does these curves. Because if the Earth's spinning and the moon is not going directly west to east, it's speeding up. That's one thing they didn't take into consideration. But I don't know what time period it was, but I found one that happened on the equinox, and it was in Russia. And it started like over in here, went west, then south, and then east. And then I had two people immediately challenge me, said, no, let's go. I'm going to prove you that this is wrong right now. And their point was that the light was coming over the top of the Earth until they saw equinox state. Then they hopped off. They're like, no, you're right. It can't be because it's an equinox state. But look at this. Here's where it started. It moves west, then south. And if it would have continued, then it would have turned to east. So you have all these different, here's one, starts here, moves west, then south, and then east. How do you explain that on the ball? You can't. You can't explain all these different paths of lunar eclipses with their model, especially if it's always supposed to go west to east. How do you explain this east to west here?
That one at the top, what crosses Greenland. Look at the length of the eclipse.
Oh, this one here. Oh, this one.
Yeah.
Wow. Yeah.
You know what I mean?
Yeah, but you know what I mean by speed. It's actually moving slower here than when it goes more south because the Earth is still spinning at the same rate of speed.
That's one hell of a eclipse, that one.
I know. If you look at that and count the time zones, how many is that going through? That is a massive amount. That's like 8 hours more, 10, 12 hours at least.
Yeah, but just so here you got 5 time zones from here to here. So just from here to here, that's 5 time zones.
And you got 5 hours between the UK and the East Coast of America.
Yeah.
Yeah,
so 5 hours.
So that's 10 right here. And actually it's inclusive, so that would be 12, really.
That's to India, Calcutta. Is that Calcutta about there?
Yeah.
Sorry.
Close. So yeah, this is probably 14, 15 hours. The only part you're missing is what? India over to Japan to West Central Canada.
Yeah, because it actually joins there, doesn't it? It's the same point nearly. That's
funny
one
too,
hell
how
of an eclipse.
Look at the different paths too. Look how wide this path is, and then how narrow this one is. I mean, this is down to a pinpoint. Now, what's the difference in the colors? Oh, annular, hybrid, total eclipse. So here we have one that was blue, and look in between. I don't know if you can see it, but there's some pink spots. Then it
Yeah,
turns red.
turns red.
So it was a total turned into an annular eclipse. Unbelievable.
Mm.
But all these are predictable. All you have to do is take this one right here, take it out, whatever it is, 18 and a half years, and it'll repeat.
Yep, that's it.
Anyway, we've been going for quite a while, Karen. You want to kind of end it, maybe? I've got a few things I have to take care of.
Yeah, we've been going for 3¼ hours now. Yeah, Chris, is there anything else you want to say?
I just want to say we need to work together.
Absolutely.
That's the most important. And if we can get a uniform frame of reference for what we want to do, improve, I think that's a big key to finding out a lot of stuff. So hopefully we can work it all out. We'll get there.
I think Rich mentioned that on a earlier hangout, maybe a year ago. Were it Rich when you said we need to, like, you know, when these executives get their heads together, they do head banging together in a office, and they get a lot more progress done. You know, when they're banging their heads together than they do that one person is just banging their own head together. You know what I mean? So if you do work together, even if it's a team of 2 or a team of 3 or a team of 4 or whatever, yeah, if you're banging heads, then you're going to make progress.
It's exponential, it really is.
Yeah, I think we're all off doing our own thing at the moment, concentrating on it. But if we all get together and work together, we can achieve quite a lot, I think. And we're getting there.
Yeah, I mean, tremendous progress for 3 years. Think about it. And most of the first year or two, we were all just trying to soak it in. We weren't really doing anything.
Scratching heads for a year first, like saying, "What's going on?"
Yeah, I've been lied to.
Yeah.
Yeah, and we'll help as much as possible. Sun and Moon will help us what we can do for you, you know, coming on here and stuff like that. So
yeah, well, I'm relying on you, Karen, for quite a lot. So you're brilliant.
Are you? Oh, okay.
I mean, you could always go on to Facebook, Chris, and start your own group up. You know what I mean? You can have like a P900 group just on Facebook, just for specifically shooting them shots you want. You know what I mean? You can have a set of instructions on the actual page of it, so you can say, yeah, I've
just got back on Facebook actually, so I'm just going to get the hang of it because I come off it under protest.
Yeah, but like I say, you know what I mean? If you did start a group up, then you could set up a set of instructions on the group. Yeah, you want a P900 with these settings. You know what I mean? I mean, if you wanted to, you could just switch the camera to moon mode. You know what I mean? The set zoom, and you switch it on, and then just go from there. And obviously, you might get, you know what I mean? Some people might be recommending other things, other settings and things like that. You know what I mean? Because the camera has got like a program mode where you can program the settings into it, and you can obviously share them set programmed.
Chris, can I ask you a question? Can I ask you a question, right? I know you're living in a neck of the woods where I used to live, more or less, right? I lived in a house and I had like a valley. I was in more or less, it was Stacksteads. You had a hill on one side and I was on another hill on another side, and there was a valley, and I could more or less see Rochdale. But where were you living in Rochdale approximately? Are you in the centre, or are you outside, or what?
No, I'm outside in the hills.
All right.
Do you know towards Bacup?
Yeah. Exactly. I lived in
Stackstead. Going towards Bacup.
Right? Yeah. Okay. Good. Yeah. But what is the percentage of people out there? Are they awake, or are they fast asleep?
There's a lot of Muslims that live in the area, and I'd say they're more everybody that's talking about stuff, but they're in their own talking about it. And I've had groups of them talking about things. I'd say it's everywhere. It's a mixture. There's not very many of that awake. Some of the older people I meet up with are very awake. I told him mine, and he was looking into flat Earth, 25, 30 years ago, and he was telling me stuff. So he just wished me luck. So,
Well, we've done a few. We've done a bit of street activism together, haven't we, Chris? I think we went to Southport together, if I remember rightly. Was it Southport? Oh.
Yeah, it's brilliant. Talking's the key, and just getting the confidence with somebody. And so when they go back again, questions, what about this? What about that? What else do you know? Because it's not just flat Earth. You find out a lot of stuff. So yeah, it is rewarding.
Yes, it is, and like I say, I was when I've been on the streets talking about flat Earth, I'm really out of my comfort zone, because you're going to a strange town, you're sleeping at strangers' houses, you know what I mean? You're waking up with strangers, and then you're going out talking about probably the most controversial subject ever known. So it is rewarding, definitely, and like I say, am I in my comfort zone when I'm out on the streets talking about flat Earth? Not really. You know what I mean? I'd rather be behind the computer doing what I enjoy. But you know what I mean? I think that is the way forward, and I think good on Harry and what's his name? Jason, for what they're doing. Like I say,
yeah,
hopefully.
Still looking for funding. Go fund me.
Actually, for everybody who goes out there and does activism, even if it's on a low level, you know, I do low level activism. I talk to people. I mean, like today, at least 15 people, we all do it. And all of us doing this is waking people up. And if we do one person a day, someday we're all there.
Well, interestingly, like I say, you've got Southport here, then you've got Speaker's Corner, which is up there, and you've got real life trolls in your face for about 5 hours, and that's quite interesting as well when you're down there, because you've got gangs of people around you, who don't believe a word you're saying, and you're the worst thing since, like, you know, I don't know what ever since, but you know what I mean. You're getting proper attack like that when you see the trolls on Facebook and on YouTube. Yeah, well, when you go to Speaker's Corner, you meet them trolls in real life. Yeah, these are the real life trolls, the guys who've had a real bad week at work or with a family, and they want to just come and take it out on somebody. Say again,
I
Karen?
saw what you put on Speaker's Corner. It was quite horrific, really. Like,
yeah,
it's like, I think I'd be saying, go away. I don't know if I could handle it myself, because
that was really... Karen. I'm just going to tell you, that was the cut version. You haven't seen the uncut version. Yeah, let's just leave it at that.
I loved every minute of it.
Yeah, so did I.
We're trying to finish, so I really hate, because obviously I bet we could probably carry on talking for another couple of hours. But Dave, do you want to say anything then about your stuff, or to Rich about?
Well, hopefully, I'm going to keep in contact with Rich. I'm back to normal now. You know what I mean? I've been away. I've had a rest, because I needed a rest, because, like I say, it's, you know what I mean. When you're working a full-time job and you're trying to do other stuff on the side, and you've got your son at the weekends, it does become quite difficult at times. And I just needed a break, just to lie in the sun for a week and gather all my strength back again, ready to kick off again. So now I'm fully recharged. Yeah, the sun's recharged me. Yeah, you know what I mean, like Superman. So I'm fully charged now. So I'm ready to go again now. So, but now I just want to concentrate on the conference and try and obviously work with Rich and try and put something together, and maybe obviously bang a few ideas together, and hopefully put something together good, what people haven't seen before, because I've got the feeling we're going to be getting a similar kind of a conference that we got last time. I mean, I hope we don't, but I hope hopefully that me and Rich can present something what's going to make people go, whoa, wow, I didn't know that. You know what I mean? And that's what we want to do. We don't want to be telling people the same old. We want to present in new stuff. And like I say, hopefully we can present something new.
Yeah, absolutely. Instead of, here's my favorite hobbies, which I think we got. I mean, that's not exactly what we got, but a lot of people talked about stuff that wasn't the subject matter, if you ask me.
Yeah, exactly. Yeah, and like I say, it's you only get one opportunity to do something like this, and you know what I mean. So I really want to get my head down and put something together good, and obviously work with Rich and get something out there what people's gonna going to look at, and you know what I mean, maybe they can get some ideas for themselves, you know what I mean? Because like I say, I always encourage people, you don't need all this fancy equipment to make observations. You just need a phone app, yeah, and you just need to document it all. That's all you need. You know what I mean? You've got on these phone apps, you've got Dioptra on Android, you've got Theodolite on iOS. You can make your own observations, yeah, and you can make your own and do your own recordings. Yeah, you don't need fancy cameras, P1000s at £1,000 a time. You know what I mean? You just need the basics, and that's what I encourage people to do. And like I say, at one time, Karen, with the Sun and Moon group, that was what the group was about, collecting all the actual readings. And that's what I'm still doing now. Every time I see the moon, I always take a snapshot with Dioptra, and I always compare it with moon calc and time and date to see if what I'm observing is where the moon should be. Do you know what I mean? And like I say, I'll carry on doing that. But all I'm doing now is going to concentrate up towards the conference. Yeah, finish the sun crossing video, what I've been working on since June. It's nearly finished now. It's about 85% finished. So hopefully I can finish this by next week, and then maybe I could come on the show and we could showcase the video. That's it.
Of course, Dave. So I couldn't unmute myself quick enough. Of course.
Cool.
Yeah.
Like I said, the video's nearly finished now. It just needs tidying up.
Yeah, boys, come back. It's possible. Talk to the people. Yeah, thanks, Dave, because I know you've got quite a lot to do, which, yeah, maybe, I don't know, you can keep in touch with Chris and stuff as well. Maybe.
Yes, like I say, if you want any help putting a group together, give me a shout, because like I say, I've got my own group on Facebook, and just like Karen, and it's been going for nearly 2.5 years now, and I've only got 3,500 members in it. It's still quite a lot, but you know what I mean. It's I don't just add people for the sake of it. When people ask to join, I look, see if they obviously fit the criteria, because I don't want any trolls in the group, and then I add them. So it is a slow. I want to try and get the group to about 5,000. But if you do want any help putting a group together, I could kick it off for you, no problem.
There you go, Chris. Right, Rich. Thank you very much, Dave. Chris,
Okay.
Rich, do you want to say anything?
No, just thanks once again for coordinating this, Karen, and getting us together. Thank you, Chris and Dave. And Chris, yeah, anything I can do with People for People to get people to coordinate everything up there, and whatever you need, I'll do whatever I can, buddy.
Thank you very much.
Oh,
You got
thanks,
it.
Rich.
Yeah.
So see if Patricia or Astral want to say anything. Patricia, Astral.
Wakey, wakey, Patricia.
Of course she's there.
I think she'd have come on by now, but yeah, her son's there, so she just listens and mutes. Anyway, carry on. You might be watching television or something. Go on then, Astral. Have you got anything to say?
Yeah, thank you, gentlemen. Chris, beautiful. Dave, awesome. Rich, love you guys. Everything you've said is brilliant. And like you said, Chris UK, it's about coming together, because when people come together, they do things together, then we can collate that and we can make sense of things, can't we?
Together, we are better.
Exactly, yeah. And just love all your ideas, and it's awesome. Thank you.
Just before you go, I want to introduce you to my new flat Earth friend. Just hang on a sec.
And also thank you to everyone who's been listening to this hangout today. Astral, I had a text from John the Morgile. He's coming on tomorrow.
Goody. Yeah, he cancelled last week because he was working, wasn't he?
Yeah.
Yeah, that's good. I love John the Morgile with his word soup.
Dave, where did you get that from?
Somewhere, I don't know. It's not mine anyway, but it is. He has a.
This is Bobby. Look at that. There's no measurable curvature on that nose.
Oh.
Hey, where did you get a gremlin from?
Is that your mum?
Yeah, we're just looking after it for a while.
Oh, right.
Yeah, I'm going to take him out for a little walk in a minute.
You know, when animals go out, they don't think they have to contemplate how to sort of do things, do they? Like, hey, we're feeling a bit here, and there was an earthquake, so we've just had a wobble. Or they don't worry about any of these things. Birds don't think about, hey, we're rotating when they're flying, do they?
Have you ever seen Lilo and Stitch?
They also don't deceive anybody.
Anyway, thanks, Dave. It's been a really great hangout, and it's good morning, good afternoon, good evening from us. Thank you, everybody. Thank you,
Thanks,
Chris,
guys.
Dave,
Thanks a lot.
thank you, Rich, Patricia, Astral, chat room.
Yeah, thank everybody, and thank you too, Karen.
Yeah,
Bye.
mwah.